Hello? Hello, hello, hello. Can you hear me? All right, it looks like everything's working fine. Are there any Pythonistas in the room? Hello, everybody. Welcome to PyCon CZ 2017. I have a few organizational things to say to you. There will be 2 rooms with talks for 2 days. That's this room, which you apparently found, and the theater is that way. There is also food upstairs. Some of you have already been there. You can reach that either by the main stairs, or there's a fire access staircase if you go out that door. So if the stairs are jammed, you can take a detour. The official hashtag of the conference is PyConCZ. If you forget, you have it on the back of your conference badge. Everything here will be live streamed to YouTube, so if you have any friends who couldn't join us, tell that to them. If you have any questions for the speakers, we're using Slido to moderate the questions. So if you go to slido.com and enter the conference hashtag, you can ask questions there, or we'll run around with the mic if you're in the audience. There is an event on Facebook, so if you know how Facebook works, you can check in there and you can get some news there. And all the food will be upstairs, so if lunch comes up, use either of the 2 staircases to get there. So that's it from the organizational side. And please let me welcome Lily Ryan, who came from Australia. She's a software and systems engineer, and she'll be talking about more drastic consequences of tech debt.
Hi. How's everyone doing? Yeah? We have slides. Brilliant. Okay. So, thank you, firstly, very much for having me here. And thank you so much also to the Czech PyCon team for putting all of this together. It's pretty great. Can we give them a round of applause, please? It's really, really great to be here. So I'm Lily Ryan, and this is my Twitter handle in case you would like to be friends on the internet, or say things to me, or send me your thoughts. And before I get into this, I want to give you all a heads up that I'm going to be talking about death. So I know the title of this talk and the abstract might have made that kind of obvious, but if that's not a topic that you want to hear about right now, that's cool. Just go grab a coffee, wait for the next talk, come back later. I am all about the consensual talk attendance. This is not mandatory. Okay? But for those of you who are keen to stay, let's talk about deadly bugs. Okay. I am fascinated by bugs. This is not just because I'm Australian and we live with 1 million of them and they could kill you at any moment. Although that is a big part of life. What I really love about bugs, at least in software, is that it means that you have to ask some really, really interesting questions in order to find them. In the last few years, I've become a professional what-if asker. I mean, my mother would tell you that I've been doing that since I was about 3, but, you know, professionally, I've been doing it for a little while now. And every time I start a new project, or I'm handed a new set of requirements, or I'm just struggling with something, I will always start to ask questions. I will pull out the what-ifs. If something isn't working, once I've understood what I want it to achieve, I want to understand what I don't want it to achieve. This can lead you to think of all kinds of things. Some of them are going to be completely wild and totally irrelevant. But asking this question enough could lead you to find things that you wonder why you didn't think of earlier. And hopefully you'll think of these things, and then you'll catch these bugs before they go on to do something nasty. So this chunk of metal was one of my very first experiences of the power of what if. I attended university at a place called Monash University, which is in Melbourne, in Australia, where I'm from. And there is a really nice garden in the front of the Department of the Civil Engineering, where we would go and we would drink coffee and pretend that we didn't have any essays to write or exams to study for because we were students. And in the middle of this garden, we have these huge, big, twisted chunks of metal. And these pieces of metal come from the Westgate Bridge, which is a bridge in Melbourne that was finished in 1978. And it connects the west side of the city to the east side of the city. Pretty central infrastructure backbone. And I use it all the time because I live in the west and I work in the east. But in 1970, when the bridge was under construction, it collapsed. and it killed 35 people. And some of the people that it killed were working on top of the building, and some of them were taking lunch in a portable building underneath the bridge. And some of the metal that I used to drink coffee next to fell on them and crushed them. Monash University, they bought some of these pieces and they installed them in this garden in front of the Department of Civil Engineering to remind the students who studied there of the consequences of mistakes in their work. In my view, it's a pretty dramatic way to do it, but it gets the point across. And it's something that I still remember, even though I attended that university several years ago and an entire career ago. So, okay, this is a strong symbol for civil engineers. But those of us who work with software fall into a different category of engineers. And when things go wrong in our work, it's not always so easy to capture a piece of that disaster and put it in the middle of a garden for future computer science students to contemplate. They're kind of intangible things sometimes. It's hard. So I wrote this talk for you instead. I'm not going to go, I mean, this is not going to go in a garden, but hopefully it will give you something to point to and look at when you're doing your own engineering. And when I'm done talking, you will have a list of 5 things that will help you avoid the software equivalent of stuff like this. So, what does a software disaster look like? Some of you, if you formally studied computer science, you might have had a course or at least a lecture about historical cases of poorly designed software that led to disasters. Courses like this tend to focus on what they call safety-critical systems. That's usually like power plant software or railway signaling software, medical software, that kind of thing, the things that make the world run properly. These kinds of courses usually involve famous historical examples of software screw-ups like the Ferrac 25, which you may have heard of. It was a radiation treatment machine in the late 1980s for cancer patients. And software bugs inside this machine caused the patients to be delivered a dose up to 10 times what they should have been of radiation. And although a lot of them were already sick, this radiation poisoning led to a lot of their very early deaths. Courses like this often also include things like the London ambulance software dispatch disaster from 1992. So in 1992, London decided that they needed to upgrade the software that they used to decide who would get an ambulance and where they would go when an ambulance was called for. Unfortunately, this software was plagued with bugs from pretty much every single level of its construction, right from the planning through to the execution, which meant that when it went live, for 2 days in the October of 1992, ambulances simply failed to show up when they were called for. And depending on the case studies you read, this led to the deaths of anywhere between 10 to 20 people who didn't get care in time. Both of these stories have gone down in the history books as things that we really want never, ever, ever to happen again. But the problem is that outside of these introductory computer science courses, we're probably never really going to think about this stuff when we work. I mean, the London ambulance disaster was really bad. But a lot of us write websites for cleaning companies. We design bank account interfaces. We write mobile apps. And these things are really cool, but they don't control medical devices, and they don't decide who gets an ambulance when it's an emergency. If they fail to function, the companies that you've written them for might lose some money, developers might get fired, but at the end of the day, nobody's going to die because of some code. But that is not quite true. I first heard about this case in Ray Nola's excellent PyCon Italia talk about Python, locales, and writing systems. And this is what kicked off my investigation into lethal software. So, in 2007, these 2 people died because of a Unicode software localization bug. This is Emin and Ramazan Çalçoban. They were a Turkish couple in the middle of a divorce, And Emin had moved out and back with her parents. And they were having an argument over SMS, as you do. Ramazan told Emin over SMS, "You change the topic every time you get backed into a corner." It's a pretty normal thing you might say to someone when you're arguing with them. The Turkish word for being backed into a corner or trapped, which I am not going to pronounce because I don't speak Turkish and I don't want to offend anybody who does. This word uses the dotless I, which is a really common letter in Turkish. That's it. Unfortunately, Emin's mobile phone software didn't support the dotless I. So she saw it as a dotted I. And the same word for being backed into a corner, when you write it with a dotted I in Turkish, looks very different. It's quite rude, and I'm not going to say it here because this is a family-friendly conference. You can look it up later if you'd like. I've got links at the end. So when Emin received it, she was very upset by what she'd read. And she showed it to her father, and he was even more upset by what he'd read. And the family, decided to call Ramazan over to the house to discuss what he had sent. And when he turned up there, Emin and her sisters attacked him with knives. And in the struggle, Ramazan managed to stab Emin with one of these knives, and she bled out at the scene, waiting for an ambulance to turn up. Ramazan was arrested, and a short while later, he died by his own hand in prison. In 2009, a GPS error killed an 11-year-old boy. So this boy, whose name was Carlos Sanchez, and his mother, Alicia, they had decided that they were going to take an overnight camping trip to Death Valley in the United States. And they used GPS to find their way to the camping site. Unfortunately, this GPS was programmed using maps that were at least a couple of decades out of date by this point. And so it instructed them to go down a series of increasingly poor roads, and they ended up trapped in a collapsed animal burrow, and they got stuck. And because they had only planned it to be an overnight camping trip, they had only brought about enough food and water for 2 days. And because it was a short trip, they hadn't really told anybody precisely where they were going, or given many details. The other thing they hadn't done was, because they were thinking, okay, we'll stay overnight, they hadn't planned for the daytime conditions in Death Valley, which can get up to 50 degrees Celsius during the summer, which it was. Unfortunately for them, it was about, Death Valley is a huge park. It was about 5 days before anybody came that way and found them, by which time Carlos had died of dehydration. In July 2016, a color detection software error contributed to the death of a 40-year-old man. So Joshua Brown was driving his Tesla car down a highway in Florida, and he had autopilot mode on. So Tesla's autopilot feature isn't quite the same as a self-driving car in the way that you would think of a self-driving car. It's designed to detect intrusions into your line of driving and skirt around accidents and things like that. It is not the kind of replacement for you taking your hands off the wheel. You shouldn't do that. And autopilot was configured mostly for recognizing things like the dots on the road or the back of a car or the front of a car. Mr. Brown was traveling at a road that was running perpendicular to another road where a big truck was coming along. And the camera in the car failed to detect the difference between the white of the side of the truck and the white of the sky. And it also wasn't used to recognizing the side of a vehicle. It was more used to recognizing the front and the back. So it didn't see the truck. And Mr. Brown didn't see the truck either. And because neither of them saw the truck, neither of them applied the brakes. And the car went through the side of the truck, and Mr. Brown died. So, I don't want to imply that any of these technologies are inherently dangerous. I mean, a lot more lives have been saved because SMS exists, and GPS, and autopilot, than lives that have been lost because of them. And every single one of these cases has led to inquiries and audits and changes in the systems that caused them to try and ensure that this stuff doesn't happen again. And we can't deny that all of these deaths were completely tragic and very sad. But as programmers, why do these things matter to us, really? I mean, nobody in any of these cases was actively writing malicious code. And the outcome might have been different if somebody had reacted differently to what they had read, or if the woman driving the GPS car had turned back when she saw the roads were getting strange instead of continuing on, or if the driver of the Tesla car had applied the brakes earlier. But the plain fact here is that your users trust you. They believe in the work that you're doing, and they believe in the goodness of your intentions. And sometimes they pay for this belief with their lives. We write code, and so we know that software isn't perfect, and it's not magic, and we're not magicians. Code is written by human beings, like everything else. But people outside of this industry don't always think like that. And to be honest, our marketers try very, very, very hard to sell the idea that we can do magic, and we are magicians, and that the technology that we develop is going to change everybody's lives and automatically make everything better and easier. When we write software, we have to remember that our users are, in some cases, literally putting their lives in our hands, and build our software according to their expectations, and not just the expectations of whoever is hopefully paying us to build it. A developer named Bill Sauer wrote this excellent article recently about how he discovered this particular fact very early on in his career. So when he was a young developer, he was working for a company that designed websites for pharmaceutical companies. And this company marketed a specific drug to teenage girls. And he was asked to make a quiz to go as part of this website. The idea being that the quiz, whatever you put into it, would ultimately recommend that you take this specific drug. And it went live, and things were going pretty well. And then news broke that this drug had been linked to depression and severe suicidal thoughts in a lot of the people who were taking it, and that one of the girls who was taking it had gone on to take her own life. And when Sora found this out, and he suddenly realized that his own sister was taking this drug. So he rang her up very quickly to let her know what he'd found out. He'd had the realization that none of us ever want to have. That some of the code that he'd written, however indirectly, even something as innocent and innocuous as a quiz, had in some way contributed to a death. Really, the main problem is that the stuff that traditional engineering courses call safety-critical systems, that's your power plant software, medical devices, public infrastructure, they are not the only safety-critical systems anymore. Everything is a safety-critical system. If you can control the lights in your house and the locks on your doors from your phone, or you can call a car from a stranger on the internet through an app, or you can order a new pair of glasses via a website. These are all things, technological things that intertwine very closely with our everyday lives. And all of them have, in some way, if you apply this what-if thinking, the potential to end in complete disaster. What if, for example, the app that you're using to lock your doors is not secured properly, and a hacker breaks in, and then steals everything, and kills everyone in the house? What if the ride that you called from your cool ride-sharing app allows drivers who are not registered to sign up for the app, and you end up in a traffic accident? Or it uses a mapping system that directs you through a dangerous neighborhood and your car is attacked? What if the glasses that you bought online were using a form that didn't record your prescription properly, And when the glasses were made up, you put them on, you can't see properly, you trip over an obstacle and fall down the stairs. So technology is embedded into every aspect of everyday life, and we rely more and more on it for every little thing. The things that we build, even the small things, can become such a critical part of the lives of our end users that we have a responsibility to take those lives seriously. And in the process of building this stuff, as Bill Sora did for every single project he joined after he wrote that quiz, we've got to ask ourselves if building these things is the right thing for the world. This is one of my favorite quotes from Jurassic Park. This is the part where Jeff Goldblum's scientist character takes the Jurassic Park management to task for their lack of understanding of the consequences of their work. Because whether we're cloning dinosaurs or we're building a Dockerized, quantum-secured blockchain for the Internet of Things devices in the cloud, the temptation of making a cool thing with this fancy buzzword technology can sometimes blind us to the reality of what these things might entail, of whether or not what we're building is going to do something good for humanity, or whether it has the potential to be a huge disaster. Just because you can, it doesn't mean that you should. Fortunately, there is a really simple way to figure out if your app is going to cause loss or death or grief, and plan to avoid that. You have to think like an astronaut. The Canadian astronaut, Chris Hadfield, who is one of my favorite people ever, he's the guy who performed the David Bowie song on the International Space Station. He speaks very often about how astronauts are taught to think before they go out into space. Literally everything that you do in space has death as one of its outcomes. There's so much training that astronauts do, and a lot of them were test pilots before they were even astronauts, so that when your plane is plummeting to the Earth and you've blacked out because of the G-force and you suddenly wake up, what you do next is down to muscle memory. You don't even have to think anymore. Astronauts take lessons from the past, and then they test and they practice, and they test and they practice, and they test and they practice, until emergencies are boring, and they know what to do without even thinking about it. Hadfield calls this the power of negative thinking. And I think that he explains it best in his own words when he says that self-help gurus are always advising us to think positively and envisage success. This is about as helpful as thinking about cupcakes. Just thinking about them isn't going to help. It's more important to think about what could go wrong in a mission. Visualize failings, not success. That's what's essential to survival as an astronaut. Now, most of us are probably not going to get to go to space or be test pilots. Although, if you are, please come and find me afterwards because I want to talk to you. But we can still work like astronauts and think like astronauts. We just have to do it on land. So this is how you become a land astronaut in 5 easy steps. Firstly, ask, what if? You have to do this at every stage of the development process. You ask it when you're planning your code, ask it when you're writing your code, and ask it when you're testing. It's easy to describe what you want your code to do. It's a lot harder to describe what you don't want it to do, and there are many, many more things that you don't want it to do. For example, I want this machine to brew coffee. I don't want it to brew plain hot water. I don't want it to catch fire. I don't want it to summon the gods from the depths of the ocean. Asking what if can be as informal as sitting down with your team every so often, or just by yourself if you work solo, and putting on your astronaut helmet and doing some negative thinking brainstorming. It doesn't matter how outlandish or how unlikely these ideas are, you will come up with some really weird ones, but eventually you will discover serious edge cases. Which you might not have found any other way. Security holes, or use or abuse cases that you may not have thought of otherwise. And once you've found these cases, it is important to document them so that you can deal with them later. Which leads us to tackling your backlog. If you're tracking your work in any way, you've probably got a list of tasks somewhere that you will get around to eventually. You need to make sure that that eventually happens. Set aside an afternoon a week to fix an annoying, seemingly inconsequential bug. Bugs are great because they're really good learning opportunities for newcomers to your project, whether it's closed or it's open source. Spend some time getting them done, get them fixed. Because annoying tasks that seemingly don't matter might, in the end, have negative, disastrous consequences. I mean, if someone had taken an afternoon in 2007 to add support for the dotless I in Turkish phone systems, 2 more people might be alive. And never say never. There is always going to be someone out there who is that edge case. So make sure that you cater for them. This is why it's important to remember that your users are people, just like you. And it's easy to get frustrated when people use our software in the way that we didn't intend them to. I mean, the tech community, unfortunately, has a pretty long history of shaming the people who allow us to keep doing what we're doing. I mean, acronyms like PEBCAC, problem exists between keyboard and chair, they've been kicking around since the 70s. That's a long time. And that means there's this ingrained belief in some parts of the technology community that the problem is never with the software, it's always with the people who are using it. But the reason that these people cause us problems, really, is it circles right back to the fact that they trust us, or they want to trust us. And they believe that we can perform miracles. So they've been sold the idea that technology will change the world, and when it doesn't perform the way that they expect it to, of course they're going to be annoyed. So when we build, we have to remember that we're building for them. And when they offer feedback, we should listen to it. A quick way to remind yourself who you're building for is to use different words for the folks who use your products. When you're working on your stuff, don't talk about users. Talk about people. If you're recording your tasks as an agile-style story, or you've got some other kind of documentation, this can be as simple as just find and replace for that one particular word. I found it, at least personally, to be a really useful way to shift my thinking. And remember that a lot of the time, these people are going to be the person standing next to you on the train, or the guy who makes your coffee, or your parents, or your children. And that's because these people are part of our lives, and in one way or another, we need to take care of them. The best way to do that as a developer is to say no to the things that we feel are going to harm others. Bill Sura, the guy who developed the online quiz, he came to a strong realization about the power of saying no. In his article, he writes, as developers, we are often the last lines of defense against potentially dangerous and unethical practices. We are the ones who build this stuff. And if all of us take a stand and say no to building things that are dangerous or unethical, then they won't get built so easily. It's a move, admittedly, that it takes a lot of determination. Sometimes it's a move that requires a certain amount of privilege to execute. It is a move that sometimes could cost you your job. But if you're in a place where you have the ability and the strength to say no to something that you don't think is right, take that stand. Isaac Asimov, the science fiction author, he's provided us, I think, a pretty useful guide for how to say no in his famous laws of robotics. So these fictional laws governed the behavior of Asimov's advanced robots in the books. And in the books, these robots lived and worked beside humans and rode trains with us and did dangerous jobs for us and helped us with everyday tasks. And the first law of robotics is what's written here. A robot may not injure a human being or, through an action, allow a human being to come to harm. We know that our cool humanoid robot future hasn't come along yet, but our laptops and our phones and the internet, in some cases, do many things that are equivalent, and in others go far beyond anything that Asimov ever dreamed. There are apps in some places that will arrange for your laundry to be picked up from your house for you, taken care of, and returned without you even thinking about it. There is increasing amount of software in your car. There are apps that track your heart rate, and there are apps that tell you to stand up when you've been sitting down for too long. All of this software is designed to make life easier for us. None of this software has anything like ethical laws built into it. This is where, in the absence of fancy robots, we need our own guiding principles. And this isn't just a thing for fictional robots. Since ancient times, doctors have had the Hippocratic Oath to guide them in decision-making when they're dealing with their patients. So things like, practice 2 things in your dealings with disease. Either help or do not harm the patient. A similar Hippocratic Oath for developers has been proposed many, many, many times in the past. But in case you feel like something to guide you, this is my suggestion for a law of software development. A developer may not build something that could injure a human being, or through inaction allow a human being to come to harm. Personally, this is what I keep in mind when I'm building new stuff. And for me, I feel that if something violates this principle, then I'm going to say no to building it. Asimov took his theories a little further in some stories. He started playing with the concept of a zeroth law. And that's something that implies that harm could be done. This focuses on the harm that could be done to all of humanity rather than to a specific individual. And if, as developers, we developed our own zeroth guiding principle, we wouldn't get software that spies on people. We wouldn't get software that perpetuates unfair power structures. We wouldn't get software that exploits workers. We wouldn't get software with built-in encryption backdoors. We, as coders, as developers, we are the ones who get the final say in what goes on online. And we have to use that power to save the world. I know it's a cliche, but seriously, with great power comes great responsibility. So please wield yours thoughtfully. And for anyone who missed any of these points, this is a slide that you probably want to take a picture of. This is how you become a land astronaut. Take these 5 things and go back to your work and take a good, long land astronaut look at it. So if you do these things, you will find, hopefully, that the bugs won't be able to bite quite so often. Thanks. Nope. All right.
All right, nothing from Slido. Do we have a question from the audience?
Okay.
Okay, so the question is, do you have any tips on how to find edge cases? Other people reviewing your tests, maybe?
That's a good one. And actually getting other people in to do the testing is also a good one. Quite often, the people who test the code are the people who write it. If you get people in who you want to use your code to test the code, they're going to find the bugs that otherwise would be found in production. Getting a wide variety of people to test it is also a really good idea. Get somebody with low vision to test your code. Get somebody who is not very tech literate to test your code. Get somebody who's very tech literate to test your code. Testing widely is the best way to find edge cases, and it's much better to do it when you're developing rather than having these things be found in production.
And the second question, what do you think about the future and security of self-driving cars?
That's a good question. After the case that I spoke about, there were a lot of reviews made of the circumstances that had led to this particular incident happening. And I know that autopilot, again, is not the same as self-driving cars, but I think that the more that we think about these things and the more that we test for these things, the more that we can evade them. I think that self-driving cars are probably an inevitability. We just need to make sure that they are the safest they can be.
Right, that's all the time we have, so thank you, Lily.
Thanks.
And if there are any motorcyclists, I just got word that there are some motorcycles parked in a way that somebody could scratch them. So if you could go outside and park somewhere else, I guess somebody will show you where's the safer place. And we'll have a break now, so go get some air, get some coffee, and see you in about 10 minutes. Hello, hello? Hello, hello? Hello, hello? Can you hear me? Hello? Hello, hello? Hello, hello? Can you hear me? Hello? Can you hear me? Hello, can you hear me? One quick announcement. It's now possible to register for workshops. So at the same place you bought your ticket on the PyCon CZ website, you can register for workshops. It's free, and there's just a limited amount of people that can fit in the room. So if you'd like to do some workshops on Saturday, go there and register. And now I'd like to welcome Jirka Vejraška, an ethical hacker from Red Team, talking about parallel processing in Python. Welcome, Jirka.
Thank you, Peter. Before I start, thanks. 2 quick thoughts on Lily's talk, which I did like a lot, if I may. One of them is, if you're interested in software bugs, do read the article about the guy whose last name was Null, N-U-L-L, and how he was invisible to computers. And also, the astronaut analogy, if you like that, Google a book or read a book called Failure is Not an Option by the guy who was on all Gemini, Mercury, and Apollo missions. He was the flight director, really good read about astronauts and their approach to testing. The last follow-up is an important announcement. I am a hacker, and unlike what Lily had said, we may occasionally unlock some doors, but we will not steal things from people's houses, and we definitely will not kill people, as far as I know. At least I don't do that. So, presentation mode. Let's do it. So, just to know the audience, who here has done some sort of parallel processing in programming outside of I have a web server, which has a lot of servers and CDN and whatnot? Quite a few hands, okay. Who's done it in pure Python only? Oh, awesome. I think you can go home. This is a backup talk. I'm filling some void because somebody couldn't make it, so it's probably not going to be as interesting as you might think. A little bit about me. As mentioned, I'm a red teamer, which basically means fancy word for hacker. I do ethical hacking for a big corporation. Before that, I was doing all sorts of security work for another even bigger corporation. And before that, I was administering pretty much everything you can think about would be IT-related in a medium-sized company. Those of you who are Czech might probably know me from some local meetups. I use Python quite a lot. Most hackers do, as far as I know, except for the younger ones who use Node and whatever else. My Python history is quite long. I've written all sorts of stuff from low-level network sniffer because TCP dump wasn't smart enough for us, to various custom password crackers, also some on-the-spot things like heartbeat scanner. When Heartbeat was announced, we did scan the company within next couple of hours using a Python code that was distributed from multiple servers. So if you have any questions about Python security, come talk to me. I have a friend. He's doing a lot of speeches, talks at the various conferences. He's also a hacker, very well known. And he says that every presentation to be successful needs 3 things. One of them is a Sun Tzu quote from a book called Art of War. Obviously, it's kind of difficult to find a related quote from a book that's 2,500 years old if you talk about Python and parallel processing. But I tried, and hopefully this will do it. So, yeah, interesting book for reading, obviously not for programmers. Also needs image of a cat. I don't really know why. So I put image of a cat on the slide. Obviously, I could only fit the head on the slide, so apologies for that. I don't really know what's the rule there, but rules are rules. Not much you can do. And the last one is a meme or alternatively XKCD slide. So there's a slide about presentations, which I think applies a lot to my talk. I'm going to be basically showing random stuff. Some of it may be code, probably broken, may contain bugs. I'll ask later afterwards. So, in my line of work, using programming is slightly different from your regular, DevOps programmer, coder, whatever you want to call it. My problem is time. I don't really have time to do anything fancy. I often need to code something very quickly, and I am quite restricted. A couple of tasks that I had to do in the last year or two, I need to resolve 90,000 DNS names pretty quickly without killing my local name server DNS resolver, and I couldn't use any third-party libraries. I couldn't even install ADNS or any of the DNS-related libraries in Python. I quite often need to crack passwords. That's what hackers do. And obviously, there are tools for that. John the Ripper is a famous one. Hashcat or one of the variants of Hashcat are awesome for cracking passwords. Unfortunately, once you find an application which uses a custom encryption algorithm, hashing algorithm, and you find a source code for it, you have everything you need. The last bit you need is convince John the Ripper or Hashcat to crack that particular format of the password because they don't do it by default. That takes time. And it's often quicker to write some simple algorithm in Python to attempt the cracking, even if the cracking itself is 10 or 100 times slower than it would be on the Hashcat or John the Ripper, because you can throw some resources at it. And for that, I need quite a few some CPU time. I need some processors. I need some kind of task distribution, because you can't do it on one laptop, or you can do it, but with the limited time we have, it just doesn't work. And pretty much anything else that you can distribute and split into small kind of work items. So, password cracking is a perfect example. You have a huge word list. It has 300,000, 300 million words, and you have to figure out if one of them can be decoded or used as a password to match to whatever formats of the password hash string you have. So, one by one, you test it. You can throw 300,000 CPU units on that and have it done very quickly. And as mentioned, I very often can't do pip install. I often can't do anything of, apt install or, yum install, whatever you have. I've broken into a machine that's on a corporate environment. It doesn't have any outside access. I'm there sort of illegally. Obviously, it's legal in my line of work. I'm an ethical hacker, but I'm done without permission of the system administrator. I don't want to install anything. I can't install anything, but I want to run something. So Python is the obvious choice for anything Linux-related, Unix-related, because it's almost always there. Any questions? Probably at the end. Yep?
Why can't you bring the Python with you? You bring it?
Yeah, why can't I bring Python? So I can almost never install anything on a machine. If it's Linux related, if it's Unix, Python is probably gonna be there. Usually Python 2, sometimes Python 3 nowadays. If it's Windows, you're out of luck. Nobody has Python installed on Windows in corporate environment. Obviously, Macs are not so present on servers. At least in my environment, I don't see Macs. So if I break into a database server, it may have Python if it's not something like AIX or any of the old style Unix stuff. But nowadays, it's usually something like Red Hat Enterprise, and I can use Python. In that case, I would use something for any task distribution. If I want to, I own 50 servers, I want them to scan all of the rest of the environment, I can deploy the code I'm going to be showing today to do that. One thing I mentioned is port scanning. That's what we do quite a lot. And obviously, it's today you have a lot of defense against port scanning. So what you want to do is scan from different sources. And distributing the port scan across multiple machines helps a lot. So you're going to be scanning one server from different endpoints, and that confuses all the detection and protection mechanisms. I guess most of you have heard about multiprocessing or multiprocessing. I'm going to be butchering the pronunciation here. It's a formal external package, became part of standard library in Python 2.6. It's very useful because it does what threading does. Most of you would be familiar with threads. Processes do the same thing, but they are kind of easier to manage on a workstation. I guess you guys mostly have heard about GIL or the GIL problem in Python, because threads that are supposed to run in parallel don't run really truly in parallel on Python, at least not on the classic one, unless you do something like Jython or any of the variants that are focused on optimizing threads. What's nice about multiprocessing is it's very simple to use. It's extremely easy. I'm going to be showing examples. If you haven't done it before, you're probably going to be amazed how simple that is. It's really no different from any example from page 3 of any beginning Python book. And multiprocessing allows you to do a lot of stuff. It can do, for example, proxy objects. So you can have machine A, you can have a machine B. Machine B has a Python process. It has a list, for example, a big list of something. And machine A can have a proxy list, which is basically a reference to the list on the other machine. So you can add items or take items from the list on the other machine. Multiprocessing can do it for you, or you can do it using multiprocessing. It's much easier, and my recommendation is to use queues for anything. So any machine-to-machine communication, use queues because they are stupidly simple to use, and they do all the complex stuff in the background. I was thinking on what to do today. As an example, obviously I'm not gonna do any hacking stuff. Company lawyers wouldn't allow me to do that if I tried. So what I'm going to be trying is to basically figure out prime numbers. That's simple enough. Everybody understands what it means. And so what I'm going to be doing is we'll have a feeder process. Multiprocessing is going to be a process. And what it will do is randomly generate some reasonably large numbers and put them in a queue. The queue is represented by the orange, brown, whatever boxes. And we'll have a few worker processes that will each take one item from the queue, figure out if the number is prime. You know, it takes a while. It doesn't really take too much time on a laptop nowadays, but I've slowed it down intentionally. And then put the result on different queue, the red one or brown one on this one, dark one. And that's really it. And there's going to be one last process that takes the results and prints them. This is stupidly simple. That's also what I've been using for 10+ years in Python to do a lot of stuff, because all you need to change if you want to do port scanning, password cracking, or anything else is to change the worker, because the whole principle of taking an item, do some work with it, and putting the result somewhere else still applies. So let's take a look at the code. This is all you need for the feeder. It's a complete code. It's a function, Python function. It takes a queue. You've seen the queue. It takes wanted is basically how many numbers I want to generate before I quit. That's all it is. And stop marker, I'm going to be talking about it in a moment. Anybody who doesn't understand the code? Awesome. This is the worker. Obviously, we have the isPrime function, which will take a number and return true or false. Simple. And really, all the worker does is it loops indefinitely. It will take one number from the queue. And we have a problem here, because this is different distributed processing. Some point we want to stop. Once we tried all the numbers we want to try, we want to tell everyone else to stop working. So we have a marker. I use something like string which says colon, colon. And when I put it in the queue, instead of a number, all the workers basically say, OK, I'm supposed to quit. And they quit. Last thing before they do it is they put a number back in the queue, because we can have 50 worker processes. We can have 200 worker processes. And if I took the number from the queue and quit, the remaining processes would still be in operation. So what I'll do is I'll take the quit message, put it back in the queue for the next process to take it, quit myself, and it will gradually, all the processes will do that and quit quickly. I'll also put the stuff into the into results queue. So the feeder or the collector, so not the feeder, the collector will know that they need to quit. I'll figure out if the number is prime, simple enough, and I put the result in the queue of the results. Collector, again, stupid simple, takes things from the queue, from the results queue, and prints them. Nothing else. The only complicated thing is, because I know the number of workers in advance, I'll be starting them. I'll count how many of them quit, and if all of them quit, I'll know there's no more results to be printed, and I can quit myself. Simple. Obviously, I need to start it all, so this is the code you need to do to start all the processes on one machine. All I'm going to be talking about is running on one machine, because you have 4-core, 8-core laptops or workstations, or even multi-core servers. So this is what you can do to utilize all the CPU power of your machine, even if you run something like 32-bit process Python, 32-bit Python. You define some basic stuff, no big surprises. Workers count how many processes to start. Queue size, really, this is pretty arbitrary. The code is flexible enough to handle anything between 5 and 5,000. You can see the stop marker. That's what I use mostly. You define 2 queues. One of them is the one on the top of the slide you've seen before. The other is for the results. And then you simply call a multiprocessing process, give it the function of the worker, read the function definition, and ask it to start. And suddenly your machine has a new process that will wait for the queue to get some data. Then we start the feeder. It will loop through a couple 100 random numbers, put them in a queue, and we ourselves will be the collector. The process that started the whole thing will be the collector. It will collect the results and print them. That's all it is. It doesn't get any more complicated than that. This is what it looks like if you run it. Really, the only interesting thing there is that the feeder managed to put all the 100 items in the queue before any of the workers managed to collect the thing. So you can see the feeder started and quit in the middle of the screen before anything else happened. All the data was waiting in the queue, and then finally the workers started working on it and putting the results in the queue. You could see that for out of 100 randomly generated numbers, we had 3 that were primes. Simple enough. That was really simple. That was one host. All we needed was just multiple processes to run on that to utilize the CPU power. Anybody knows how to do it on multiple machines? Yep, I can see a hand. That's really it. Worker, no surprises there. Same worker, define a manager, have a queue, connect. It works. And that's it. That's really all you need to know. So, do you have a question? Yeah, it's not so interesting why it's running. I'll change the fonts on the other ones quickly. On the other side, I have the distributed server. It does nothing. It basically opens the network port and starts listening. I have this is going to be fun. And all of these windows, I'm going to quit this one because that's the single machine. All of these windows could run on a machine. At the moment, as we speak, I have a port scanner running across multiple data centers. One of them is in the US, one of them is in Europe, and the server is in Lake, and they basically work together. So what you see in a laptop is actually running on multiple machines across the globe and working pretty much exactly the same code. So I've started a feeder, so it's feeding the queue, and I've started one worker that's calculating the results. I'm going to start 2 more, just not change the font to save time. And the last item, so I have feeder, distributed server, and 3 workers. And the last item I haven't started yet is the collector. It doesn't really matter which order you started because you're using queues, and if the code can't put any more items in the queue, it will wait. You can decide if you want to wait until the queue is empty, or you wanted to basically try and basically throw an exception if it doesn't work and try again with some delay or something. So we have queue.put to wait and queue.put underscore no wait, and it will basically throw an exception that queue is full. And all we need to do is collect results. We had quite a few results waiting in a queue, and now we are waiting for some more to appear if some numbers actually do happen to be prime. That's really it. There's nothing more. This has worked for me for 10 years for all sorts of tasks, and it's, as you saw, the code is really, really simple. Any more questions? Yep.
So how, like, this is interesting because it reflects a lot of stuff like RabbitMQ and other messaging queues. Is this basically close to feature complete in terms of like some of the pub sub and other messaging queue models that are available from other products?
No. No pub sub. This is really the basic Python, so Python queues. It's good enough for, kind of proof of concept or stuff. Obviously, if you want to do anything major, you have MQs, whatever, ZOMQ, RabbitMQ, Redis, something like that. So this is really, if you're constrained and you can't use any of that, it's good enough. It's really difficult not to start a guy sitting upside down above you guys.
Any more questions?
Okay.
All right.
Thank you.
Thank you, Jirka. And the next presentation will start in about 15 minutes. Hello, hello, hello. Hello, hello. Can you hear me? Is this thing on? Je to zaplý? Hello, hello. Hello, hello. Hello, hello. Hello, hello. Can you hear me? Ah, perfect. So one more quick announcement. If you're registering for the workshops, please take note that there are parallel tracks for the workshops. So if you register for 2 workshops that are at the same time, you would have to clone yourself, which we don't think is possible, so we'd have to cancel your ticket. So please check if you can actually make it to the workshops you register for. Thanks. And that's done. So please welcome Honza Čepek, an operating systems engineer at Brains and Slushpool, who will be talking about MicroPython on the water.
Hi, are you ready for the lunch? So let's be quick and we get to lunch first. I'm going to play a video showing a small use case, which is just my pure hobby and interest. There's no business related to it. And then we talk about MicroPython and how to actually use it in real-time environment, which means you have an embedded system, a small electronic device that runs very low-level code, very simple, very low resources, not enough memory, not enough flash memory for the program, and you have some real-time deadlines, and you want to meet them, and at the same time you want to enjoy the comfort of programming in Python. Let's go. In your cinemas. Okay, you notice there are some boats, many of them. You can think of them as formal ones. There's not many places for mistakes, but it's still only a hobby and we do it for fun. So no people usually get injured, even though it's a little bit dangerous occasionally. And the hobby was somehow stuck for past 10 years and people were working on the mechanical part because that's where all these hobbies used to they usually come from machining circles, so they know how to produce something on a lathe or on a milling machine, but they don't know much about electronics. And I decided, let's move this a bit further. There should be a lot of things that you can automate, that you can measure, that you can control. And I was thinking, well, I could do it in C, because my background is embedded systems. We set a company about 6 years ago doing projects for industry automation. And what turns out that the industry is actually facing exactly the same problem. They are building applications in C. They cannot usually afford C++ on those types of systems because the resources are limited. And their code base is growing. And the problem is that one part of the code base is always the same, is the low-level part, the drivers, the abstractions of the hardware. But the business logic changes. And this is where all the mistakes usually occur. And I'm happy you were here at the first talk, because it's somehow related. We don't have too much place for for mistakes in those applications. It's always nice to talk about it, but the actual implementation is what counts. So if I was to present this to our customer, even though we are not in this business anymore, we like Bitcoins already, the marketing slides, they always are good, but the real application is something that could convince the customer to use it. And the system that I tried demonstrating, basically what I did is I used a real-time kernel, this time as a free RTOS, and I put MicroPython on top of it as one of its tasks. This picture actually demonstrates what the boat setup somehow looks like. It's got an engine and propeller and a rudder, nothing special. This is a special part, it's an exhaust pipe, but it's actually a supercharger because it's a two-cycle engine. So all the magic in the power of the boat is here. And this is where the real-time part comes in. Very critical. The reason why I tried doing it with Python in this combination is that it allows me to quickly prototype and change different things while keeping the core, which maintains this, very stable. Okay. First, I would like to describe the control system, just the basics, what's going on. So there's the engine. We're measuring the RPMs. It's the ECU where we are running all our stuff. Based on the RPMs, the ECU is actually giving some commands to a servo that's adjusting pipe length, and this is where the top power is being generated. So this is where you need to be on time. The engine reacts very quickly. It's very surprising, even though all other processes in this physical system are very slow, like temperatures. But this part, you move the pipe and the engine reacts in like 50 milliseconds, which is for a desktop scheduler. If you have your Linux, it's like 100 milliseconds, it's nothing. That's the usual turnaround in our desktop application. So, and it's also a surprising thing for me as well. At the same time, we're measuring gas temperatures in the exhaust. It's just a feedback for the ECU so that it can adjust the mixture. And we're monitoring the plug. Plug is not a spark plug, but it's like it has a filament in it, and it heats up every cycle and starts the burning cycle. The ECU is dumping some data to an SD card, so you have a very detailed log. And at the same time, it's maintaining an RF link with the pilot, which is me. So I can change some small settings, but there's not too much time in the race. So, and obviously, I get some GPS data, coordinates, and speeds. This is me as the driver. Maybe you noticed on the pontoon, there were never only single driver, but the driver always had a person standing next to him, and he was actually navigating him. So this part, it's a cell phone connected through Bluetooth to the transmitter. So I'm giving the commands to the boat to steer and throttle. But the guy, it's called pitman for us, is actually watching the telemetry data of the engine like in Formula 1. And he's telling me something's going wrong. That's it. Nice toy. The layout of the whole system is not very surprising. But I just wanted to point out that we're in a real-time operating system. Basically, it's nothing special. It's just a task scheduler. Those systems have no memory management unit. At the best case, they have a memory protection unit, but that's it. So the RTOS is pretty much a scheduler of various tasks, where for this particular case, we have two real-time tasks. One is responsible for the engine control, moving the pipe online based on the RPM. So those two tasks cooperate. I need a separate task to measure the RPMs. Then we have the communication task with the radio, even though it's not that much time critical, but for synchronization purposes, because the transmitter is streaming data continuously. You don't want to miss frames. You can throw them away, but you don't want to miss them because then you have problem with synchronization. And then you have some slow processes or tasks. One is measuring different sensors that are slow in nature, like the data from the GPS you get every 1 second, I think. And the temperature also is not changing that quickly. So you don't need a high priority task for that. And finally, you have MicroPython that actually deals with me because he is providing the data that the Fitman sees. And he's storing the data on the SD card and configuring this part based on something that has been stored on the SD card. Let's look at a piece of code, which is Python. Can you read it a bit? Okay. This is nothing special for people who write code. Basically, it's reading configuration of the pipe because it needs to do some interpolation. But I point out two specific places. String expansion, very easy to do in Python, but think of a poor C programmer that is supposed to write a software in C environment, not being allowed to use all the C library calls, like malloc, scanf, and so on. And if he uses them, he's never sure what it actually does. It's a big problem, even though there are clones of C library for embedded systems. It's called newlib. But still, you don't want to trust it, and you don't want to use it in real-time systems where you have deadlines. So those parts are painful for the C programmer because he never knows what it really does under the hood. It's calling malloc, freeing buffers, fragmenting some heap memory, and that's not good. So if you carry out this piece of code in Python, it's very easy. Similarly, when you're reading some configuration, you probably want to parse some numbers. Again, Python just does the job for us and does it very quickly and properly. Doing a tokenizer in C, you probably have some C calls in the C library, but again, you never know what they're really doing and if they do it right. There are many bugs. And usually those format strings, sorry. Oops. Those format strings are the sources of many buffer overflows in the nature. So it's good we can do it here. And actually, when you write the drivers, you never get to use any of that pretty much. So that's the cool part. One part is still missing, and that's the async programming. You know, in Python 3, which is the version that is implemented in MicroPython or MicroPython, there's a support for all the async primitives, but your responsibility is either to use async IO implementation or provide your own even loop driver. And having this integrated in a real-time environment is a bit of a challenge. So I didn't spend much time on that, but it would be really cool because you can sort of micro-schedule within the entire MicroPython task. And what that yields, it gives you a very nicely organized code, and at the same time, you don't have to care about the deadlines. Maybe you're asking, so why don't you take the whole MicroPython as is and put it on this board? Technically, it's feasible. Throw away the RTOS and just do all this stuff entirely in Python and use async in MicroPython as is. The problem is that you never know the deadlines because in MicroPython, you have the garbage collector. So that's the price you're paying for the comfort of having all these nice things that you have in Python. And the garbage collector is putting jitter in a real-time system. So you want to design your system so that one part has no deadlines, has no restrictions, which is the MicroPython part, and then the one with the deadlines would be the C part. When MicroPython came out, it was probably back in 2014, I was very excited that a project like this was finally feasible on bare metal systems, so on those class of devices that have very low memory and, well, almost medium-sized flash. Today, the devices are about 128, 256K, even 1 megabyte of flash. But the problem is that the main business of the MicroPython project was the PyBoard. So what they did is they provided the whole MicroPython as an application. And their idea was to allow plain users who know how to program in Python do actually some embedded work. Well, this is very good if you want to control your sprinkler in the garden or non-critical part in regular life, even though I think even sprinkler could cause some damage. But it would be nice if you can use and take all these benefits in industry. So I didn't like that they put all these components together. And if you look actually in the repository, it's still almost in the same state for past 2 years. So it contains all the examples, it contains all the different architectures, a lot of duplicate code in the drivers. So when you switch a platform, you never know if it's going to work because there could be a bug in the hull. Anyways, and I thought it was a pity. So let's isolate the core, figure out how to integrate it with the rest of the world. By the rest of the world, I mean the real-time operating systems and your tasks. That would be actually a feasible solution even for existing companies, because they can think of isolating their business logic out of their real-time application to Python and leave the bottom. A lot of companies use FreeRTOS. It's very, very widely used. And leave the core as is without touching it. You just isolate stuff into one extra task. That's it. So that was my idea. But the problem is, who should build this? And by building, I mean the compilation. Because the components that we have here is the FreeRTOS. We have MicroPython. We probably have tons of libraries that are maybe internal, specific for each company and his domain, and some common libraries. Like in this project, I've reused some GPS parsing library. And there are two parts missing in this puzzle. One of them is something that would let you configure things. So what we did, we took the same approach as Linux kernel does. I'm not saying this is the only way and it's ideal, but basically we wanted to have the same kind of configuration that's available in Linux kernel in any ecosystem that you create. So that doesn't mean this is fixed. If you decide you don't like FreeRTOS and you put NATX in there, you can integrate with it. If you have your own library, you can easily add configurations similar in the same way like Linux kernel does. And I have purposely expanded here the MicroPython part here. Not sure if it's really visible. It's just a subset of all the features that Python right now has, the MicroPython right now has. But it at least tries to export these to the user. I don't know if anybody of you saw the sources of regular embedded projects, and MicroPython is one of them. What they do, they usually distribute the sources and tell you, okay, here's the header, and you're supposed to change those defines, and the thing is going to behave differently. Well, this is nice, but first of all, how am I supposed to know all this? Well, maybe it's documented. And second, it's difficult and not obvious how to integrate it with the rest of your code base. And we wanted this to be independent. So we've created the descriptors, which are kconfig files, as you may know from the Linux kernel. And now the main part, who will build this? And the answer is maybe obvious. Well, I'm building Python, so I want to use Python. So I took sconce. Sconce is already a very mature project written in Python. And unlike make, it provides a very streamlined process when you're designing your build system and build environment. Actually, what it wants from you is to define your dependencies properly, and that's it. And sconce does the rest. Unlike make, you may have seen how Linux kernel build system looks like. It's actually very smooth, because what you do is you only define a bunch of object files. It's a pity that this is at the very end, but this is a trick that actually conditionally enables some module. But if you see, or if you check what's behind this, that's a mess. This is how we are supposed to use a build system, but this is not how you are supposed to use make. Because what's behind this is recursive execution of the whole build system, which is very difficult to debug and very difficult to change or extend. So in one of the first iterations that we had, we were actually using make for this for a couple of years. Some of our customers still have this build system based on make. It works, but you come to a limitation, and the limitation actually came with MicroPython. And the reason was that you are forced to generate code. With Python, it's really cool. You can have a Python script, and let's say your application requires a CRC generator. So let's take a CRC implementation, give it some polynom, and this code would be able to do the CRC calculation, the redundancy check, in Python. At the same time, it could generate a piece of C table for the CRC calculator of the generator. And you want to build this together. And when you are facing those kind of challenges, when you have to generate different parts of code, then you start thinking, okay, well, let's hack this into the build system. And then when the features start adding, you say, okay, I quit. I'll have a look around. If there is something better that will let me do this more efficiently and more easily. And this is where Python comes in again. And this is the reason why I actually choose sconce. I was looking at different build systems from what's being used in Java, I forgot, to CMake and others, but none of them fulfilled all these requirements. And the nice benefit that any piece of Python code that you actually can run, you can run it inside of the build system, simplifies the whole thing tremendously. What I'm going to show next doesn't look nicer than this, but it's more extensible. The list is pretty much the same. The problem is that's a little bit more verbose. On the other hand, whoever saw Python before recognizes this as a plain Python. Even though this doesn't run as a regular Python, because this is parsed by sconce and then interpreted at the right time when it's supposed to be run, it pretty much does the same thing like the makefile before. So we have a list of modules that generate an object. This is a QString object, and this is where we had to implement this in sconce, because in MicroPython, you are forced to scan your C source files for something called QStrings. So we just made an extension saying this is not going to be a regular object file like you know from make, but it would be a special object file that before it's being generated, you want to have it scanned and generate the QStrings. At the bottom, as a similar feature, just conditionally enabled based on your selection. So this is some USS, micro SSL Python external module. I wanted to show just a snippet of the kconfig. It is nothing spectacular or surprising. You would see this in Linux kernel. The kconfig language has some limits It is not ideal. We are still looking for, or we used to look for a better solution. But to prove that the concept would actually work, we decided to give it a try. So this example just shows how you define an option to control a micro SSL module, and then it's disabled by default. And that's what you saw in here. Oh, sorry, it was in external modules. Are there any questions? The URL has links to the presentation. It has links to the sconce tool that we have developed for this, because sconce would not really do this natively. You have to write your own tool, which is nice. That's the standard way how you extend it. And there are a bunch of notes about this presentation. There is also a link for our branch of MicroPython and the demo that's actually running on the boat. I don't know how much time we have. 26. I have a demo prepared. I'm not sure if it would be very ergonomic to view it, but let's give it a try, unless there are questions.
There are a few questions from Slido. Did you consider running MicroPython with the garbage collector disabled? Would that be feasible?
I tried at the very beginning with my experiments, because those were my initial thoughts. At the time, I think it was still version 1.6. Now we have 1.9, and this runs on 1.8. It didn't work. There was some bug that would prevent it to run without the garbage collector. I was talking to the developers about this, and then I just decided, okay, garbage collector is not so bad for this application. But if I had some special application where I am not allowed to even do garbage collecting, I would consider that.
Okay, thanks. And does the garbage collector add so much jitter? Couldn't you get at least under some soft real-time constraints?
You would. I'm not saying that this whole application would not run on the board. You would probably made it. It's not really that much critical, but I wanted to prove a concept. You cannot come to a company and saying, okay, you're going to throw away all your code and you just run everything in Python. They would be scared. You can tell it to a bank, switch your e-banking. I tried to Raiffeisen, it's taking like 4 years. Because the basic rule is don't mess with things that work. So slowly.
And did you actually win the race?
Did I what?
Win the race with the boats.
Oh, this one. Actually, it's a promo video from a friend of mine in Poland. I was not in this race, but he was actually sending it to me to come to there. But from the results, I am the champion for the Czech Republic, but I don't have a global impact yet. But I'm getting to it. But you see, my focus there is the electronics. That's why I put it there. The boats are adrenaline, but I personally enjoy the hobby because of the technical background in it.
So, what's the next step? Could you develop a self-driving boat to win the race?
Wow. Well, I was already thinking about Cool. Okay. I'm going to reset it again because I want to show you the boot. Okay. So the system is running now. Since I don't have an SD card in it, it just stopped operating in terms of the MicroPython task, and it just jumped into an interpreter, which is pretty cool. So the point of the demonstration is to show that the whole real-time part is actually running. All the tasks are actually measuring stuff. And you can interactively talk to it. Unfortunately, I was not able to mirror my display of my cell phone on the computer. It usually dies after a few seconds. So I cannot show you how I can send the sensors to my cell phone, because that's what the application is doing in the background when it's running and the SD card is in there. But I can show you how easily I can actually talk to the board. Let's say we want to get the exhaust gas temperature and whatever, some GPS stuff, but there's going to be no GPS here. We're covered on the roof. So we'll import the application. This is a convention that you can choose, whatever. I just decided it's going to be an app. This is a C code. There is no Python behind the app, and it's directly extending the MicroPython environment. This is the instance of the application. And the cool thing is that the REPL has code completion. So you see what options we have. Let's see, I want to see the temperature. We're getting 25 degrees and 25.3. I wish I had a coffee here, but I can show you this is the exhaust probe. It's measuring something like 400. If I hold it for a little bit, we should at least get some increase. Yeah, it's going to take a bit. I cooled it. Okay, let's try it later. But the demo works, I think. It's pretty good for a demo, I think. Let's talk to the GPS. If she tells anything, no, she won't. She has no signal. And the same thing is with the RPM sensor, which I could have demoed if I took a piece of magnet with me. So this is pretty much it. I hope you like it. It's no science. It's really only pure engineering, putting things and bricks together and playing with it. And that's why I do it.
Thanks, Honza. And see everyone in about 10 minutes. Great. Welcome back. If you'll be here in the evening, there will be some lightning talks. If you would like to give a lightning talk, there's a sign-up sheet next to the door you came in by. So sign up there. We'll be happy to hear you. Lightning talks are 5 minutes in the evening. They're one of the best things about the conference, so please sign up. With that, I'd like to introduce Pavel, who is a backend systems engineer and a gamer and an evangelist of continuous learning. And he'll be talking about the second hardest thing in computer science. Welcome, Pavel.
Hello. Thanks for coming. Let's start by defining what the second hardest problem in IT is. First quote that appeared around 90s said that first thing is cache invalidation, and second one, naming things. Then somebody added one more to the list, one-off error. And then somebody improved it even further at the beginning of 21st century. It was Matthias Veres that said, we have two problems in IT. Exactly once delivery, guaranteed order of messages, and exactly once delivery. And yeah, so that's a quick recap for those who don't know about what is perceived as a biggest issue in IT. I'm Pavel Leftak. You can reach me at Twitter. Slides will be online later today, I think. Okay, so I will focus on naming things. Naming things, and by things, I mean anything really that isn't a keyword, isn't an operation. So variables, methods, classes, modules, comments, anything really that is up to you how it's named. So let me start by saying that you don't write your code for the CPU unless you're using assembler, but I assume you're using Python, right? So you're not writing your code for interpreters as well. Interpreters doesn't care how your code is written as long as it's correct. You don't code for compiler as well. Well, maybe you're writing for Skynet, but that means John Connor is dead and didn't succeed. Maybe you're writing for Matrix, but then again, you're watching too many movies. Basically, we're coding for people. In the end, we're coding for end users, but until app is released and ready to be used, you're coding mostly for other developers. Because other developers need to work with your code, they need to maintain it, extend it, fix bugs, and so on. And this group of other developers also includes future yourself. Because in a few weeks, few months from now, you will not remember how it works, why it was implemented that way and not another. So please keep in mind that you're also writing for your future self as well. There's this common advice that you should write code as a book, write code as a prose, and well-written code should be read like a good book. And if those advices are hard to understand, then take this one that, yeah, I'm not going to read it. Let that sink in. Okay. Most important thing about naming is comprehension, because good naming improves how easy it is to understand your code, how well your intentions are known to other developers. And identifiers that make up for classes, variables, methods, comments, and so on are the biggest source of information, of knowledge about your application, except for documentation. There was a research done that said around 70% of all characters in your code are identifiers. So around 30% of words are identifiers, but up to 70% are characters that made up information that holds some knowledge, some information to the programmer, you, me, other people. So if we were coding for CPU, interpreter, things like that, it wouldn't matter what kind of names we're using, right? It could be anything really. But code like this isn't easily understood. You have to read the implementation to figure out what it's doing exactly. But if we use proper naming, like this, you can see just by looking at method name that it's counting a median value from given list. Simple as that. So you can often hear that you should write self-documenting code. Self-documenting code is code that you understand just by reading it, and you don't need extra explanation in comments, in documentation, what it's doing exactly. Programming is this thing we're doing between problem domain and programming domain. We need to do some kind of translation from the problem domain we're trying to implement, then translate it into somehow, maybe using simpler words, maybe using other dictionary, and then at the end, it ends up in the code using programming domain. And once we have the application written, this code that was written is being reconstructed the other way around. So by reading the code, you try to figure out the whole domain, what the original problem was. So the better you write your code, the better you will understand the domain later. And that's where DDD, that stands for domain-driven design, is a huge win, because domain focuses on designing entities, objects, not simple classes, objects that have no relations to the domain. You try to figure out the full domain and then implement it at the end. So let's start with some examples. Do you know what's the worst variable name? It's data. What does this name tell us? Nothing really. Every variable holds some data. So it's like calling a method process something. Every method is processing some data, so it isn't helpful at all. Don't do that. What's the second worst name? Data 2. That's funny because it's true. Some people use variables named like that. Let's see at this code sample. We have some variables like price, quantity, total, discount, and total is repeated 3 times. Total 2, and total 3. If we look at the if condition, if total 2 is less than total 3, then print something. Would you understand what it does exactly in this case? I guess not. You would have to read the previous implementation of what total 2 and total 3 is exactly. So don't do this. Write meaningful names like this. And right now, it reads like a book. If payable total is less than available funds, you can't afford this order. Simple as that. No need to read some additional code to understand it fully. Recently at PyCon Web in Munich, Rachel Wilmer said that no one sets out to write legacy code. You don't sit at your keyboard thinking, what kind of legacy code could I write right now? Everybody tries to write perfect code. Everybody wants it to be the best code written so far. But the truth is, it's not always so easy to keep this guard on quality level. There's the story from crime prevention about broken windows. Basically, it says that if there's a single act of vandalism, sooner than later, more acts of vandalism will repeat itself. But if there is no vandalism, then you will have to wait longer till one appears. And regarding programming, it works a very similar way. If we keep guard on code quality will be good as long as we watch for it. But once you allow somebody to do some quick fix, some quick workaround, he says, hey, it's a bug on production, we need to fix it, there's no time to do it properly, there's no time for tests, and then you fail. Because if you allow it once, it will repeat sooner than later, again and again and again, and your code finally will decay. It will degrade in quality, and, well, it'll become legacy even before it's released. Sometimes bad usage of design patterns lead to bad code. So this is some random comment from Hacker News. Yeah, it's also funny. Fortunately, in Python, it's not so common, but it happens. So I'm not going to talk about PEP8. PEP8 basically says something about how variables should be written regarding syntax, but it doesn't say anything really about semantics. And semantics is what holds information about the domain in your application. So that's what I want to focus on. So one of the most common issues, well, in Python we don't have much getters because everything is public, but there's this thing called pseudo-getter, or getter that isn't really a getter. Typical getter should just return some attribute of a class, right? But sometimes you get some additional operation inside getter. So it states that it does only one thing. Any other way around, it says that it does many things like user creation, email sending, whatever else, and it's called just create user. So again, it's very misleading. Another common problem is abbreviations. Like, just seeing this, for example, you can't be sure whether pos is for positive, position, or whatever else. Mod could be module, model, modulo, and so on. So please don't use abbreviations unless you really have to. For the compiler or for the interpreter, it doesn't matter what names are you using. It's for you, for other developers, it should be really meaningful. So please do that. Another not so obvious issue you can have is using synonyms. When you use different words for same entity, same domain object, you can introduce some confusion into the code. For example, you can have a variable called user and customer. Somebody can interpret it as the same thing with different names, and somebody else can think that it's totally different thing. Customer is user that is paying, and user just uses your service. So it depends on your domain. So don't use synonyms. Ideally, you should use same name in every place where variable has same meaning. Yeah. Another thing, that thing manager, user manager, string manager, product manager. Somebody said project manager. Manager basically is same as data. It doesn't say anything. It can do everything and nothing at the same time. So instead of calling a class manager, use meaningful names: builder, writer, adapter, handler, whatever. Sorry. Describe what this class is responsible for. Don't use meaningless manager suffix. This one is pretty easy and hard to spot at the same time. Magic numbers. you can do some checks using number that in itself doesn't hold any value. So instead of comparing to some magic numbers, please try to introduce consts or reuse some existing constants. So again, this code, when you read it, it reads like a book, more or less. I already talked to you about comments and documentation, but there's one more thing, like useless comment. Useless comment is comment that doesn't give you any value, really. It repeats what the method name says, or tries to explain how it's implemented or what is implemented. I don't need to know what or how it's being done, because I can get it from reading the implementation. I want to know why something is done, why this method was implemented this way, why this algorithm was used, why should I use this method or class, or why I shouldn't use it in some cases. That's what should be available in comments. So you can sum up all those bad practices into few rules. Well, it's variations of two rules, really. Method does more or less than it says. It does or contains the opposite of what it says. So, yeah, there are some good practices. Specific names. Don't use name that is generic, that could be misunderstood or has several meanings. Use as specific name as possible. So instead of calling a method transformation, try to describe what kind of transformation it is. Is it converting between a list and JSON or something else? Try to give your intentions in the name. And names should be short, but not abbreviated. It should be short and meaningful at the same time. There was this example of really meaningful but very long name. It was something like, it was one variable name that said, it is Christmas time, and developers are forced to write dirty hex so customers can be happy. Equals false. Yeah, so don't do that. Use short names. But, in some cases, like loops, one-letter variables are okay, because it's short scope, you can easily comprehend it, but in other cases, don't use one-letter variables. And don't use negation. Because when you have a negation method name, and then again you need to add not before calling it, it's so much harder to figure out what it actually does. So instead of is not enabled, just use is enabled or is disabled. It's so much easier to read, especially if you add a negation in a if statement. And again, consistent names, meaning that you should reuse same names in different places instead of using synonyms or things like that. Another very important thing is single responsibility. If a method has single responsibility, just one role, then it's very easy to name it. You don't need to figure out what proper name for the method would be, or for a variable would be. Variable has single role, and in such case, its naming is very simple. And try to use domain terms, domain from DDD. Because when you are using domain words in your code, it's much easier to talk later on with domain expert or with customer, because you are working with same terms. If you do some translation from domain to programming and try to use different terms, it again introduces confusion to mutual understanding. Think about it. You should spend, I don't know, a minute, 2, 5 maybe if you need to, and think what the best possible name would be. Best and at the same time really simple. Yeah. Okay. Another thing. Oh, it didn't work. Sorry. Python allows us to use some Unicode characters, but it doesn't mean you should use them in your variable names, in your classes names. Use ASCII characters only, because it's then again, there's no place for some mistakes if you're using only ASCII. Another thing, there's a thing called Hungarian notation, because there is such thing. Again, it doesn't mean you should use it. Instead of indicating what type variable holds, just try to express it in the name. So instead of adding a list, like host list, just use hosts or something like that. It again doesn't, that way you don't put information about its type, but you can figure out just by looking at the name. Yeah, so how could we enforce all those good patterns and get rid of the bad patterns? First thing, you should agree on good standards, good coding standards within your team you're working. You need to talk things through, agree what is good for you, what is not, what you will try to avoid. And ideally, you should write it down somewhere, like wiki page or something like that. Well, there's no better way to get better at naming than practice. So try to figure out best name in each case you have to write. And improve your vocabulary, because in most cases, we are using English language in our code, and English is often not our native language. So by improving our vocabulary, we can get more possibilities to how to name our variables. So instead of calling class whatever manager, we can find appropriate word to say what it really does. And refactor. Refactor is the easiest way to improve naming in your code, because good IDEs like PyCharm allows you to rename a method, class, whatever you're using in one place, and it replaces it and its usages in all places. Code review. Code review is a place where you try to keep code quality on the highest level. Because, talking about code reviews is a topic for another talk, but basically it should be as small as possible. It should be one logical change. And that's the place when you can spot bug naming, suggest how to improve it. That's one of the ways you can say you shall not pass to the bad code. Yeah, code ownership is something that is, I think, not really popular, but we should feel like owners of our code. It's not something that we write and then try to forget the next day, next month in project. We want to be proud of our code, and we won't be proud if our code is bad, right? So if we try to feel as owners of this code and want this code to be as good as possible, it will be, because we'll keep guard on code quality again. Another thing is a role that has team leader. I think it's the final quality gate for the code that gets checked into a repository. Once you agree on coding standards within your team, maybe some bug naming passed through code review. Team lead is person that is responsible for for keeping the standards that you all agreed on. And well, it could be team lead, it could be some dedicated person that would do this. But if, well, basically everybody could do it. Like when code is sent for review, but on the other hand, you can dedicate one person that would deal only with that. Yeah, here are all the links for materials and research I used in my talk. It will be later online, so you will be able to easily find it. Thank you much.
Thank you.
Do you have any questions?
So there are a few questions on Slido. So what are naming advices specific to Python and not applicable to other programming languages?
Okay, well, most of the rules are really applicable to most languages. I can't really think of anything Python specific, really.
There is a common misconception that you can use ID, but that's a function, so you shouldn't.
Oh, yeah.
Hey, thanks. So next question. Pepade has advice on how to write pretty syntax. Is there a similar document that would suggest good names for things? Or should we use your presentation?
I didn't find anything like that, but Pepade says only about syntax. But if you look at the slide with links later, you will see some research papers that try to figure out how to write better names. One of them says about a thing called linguistic anti-patterns. Basically, it's some of the things I mentioned, that method is saying one thing and does another. So, yeah, you should read those papers with PDFs. Yep.
Thanks. And what can you say about smart naming tools, ML-inspired, that, for example, suggest names during coding or even refactors the whole code for better comprehension?
Well, one of the research paper mentions a tool for Java code that tries to figure out where there's a mismatch between name and what is returned, or things like that. But personally, I have limited trust to automated tools like that. You are the best person to say what it really does, not a machine. That's my opinion.
Yeah, but how about...
Yeah, it was my question. So, but how about if you already got a source code with hundreds of millions of lines of code and it's really bad and named? So something like that would be really useful, right? Like a tool that can crunch it and try to figure out, at least the naming, it's better than nothing.
Yeah, well, I guess when you have code this big, a tool of this kind would help you to spot bad patterns. You wouldn't use it to fix the code because it's too big, but it will help you to spot bad usages, bad naming, and fix it case by case in future, or to consider it in future code.
So you can fix it by refactoring the variables.
Yes, you can use refactoring to fix that.
So are you aware of any good tools already out there?
Like I said, I think PyCharm has really good refactoring tool.
Yeah, but still, you need to use it as a developer, right? But I'm talking about something automated with machine learning.
Okay, I'm not aware of any tool that would use machine learning for that.
Yeah, okay.
Right, and the last question on Slido, is code annotating a good practice in Python?
do you mean by code annotating?
I think that's the type annotations in Python 3. It's the ask around.
Okay.
Clarify now.
So I personally think, yeah, it's a good idea. If we have this available finally in Python 3, we should use it.
Okay, thank you. Are there any more questions from the audience? Well, I see everybody wants to go to lunch. Oh, here's one.
When you talk about the vocabulary and making it as fancy as possible, isn't that sometimes an overkill? What if your English is so fancy that you use words that, you know, are too fancy, like Shakespearean words, or right? That makes it a bit harder to understand because every time you read a variable, you need to open a dictionary or Wikipedia to understand it, right? Where is the line for this?
Well, basically, you should, most cases, use words that are available in dictionary. You shouldn't make up words. Another bad practice that I didn't talk about is when you combine two words to represent some new entity. So you have a company and person. When you combine it, you have company person. Instead of that, you can just say it's an employee, right? It's shorter, it's more, well, easy to read, to understand what it really does. There's no place for any confusion or more misunderstanding.
Okay, so what is your advice on the line here? I mean, should you keep back if you just come up with a really specific word, but which is really like only native speakers would know this and not...
Some people say that to communicate in English you need around 5,000 words. So I think you will be able to find a word in this number to name your variables, name your things in the code. If you need some really fancy words that nobody would understand, well, either you don't need it, or there's a simpler way to call it.
Okay.
Okay. Thank you.
All right. Thank you, Pavel.
Thank you.
And there should be some food upstairs, so please help us get rid of it.
This is a Cinema Beats production.
Tomorrow's production available in today's market. Upgrade your sounds today and start making hits.
Cinema Beats. This is a Cinema Beats production. Cinema Beats.
Can you hear me? Can you hear me? All right. Welcome, everybody. Again, some organizational things. Please sign up for the lightning talks on the sign-up sheet over there. Please sign up for workshops on Saturday on PyCon.cz. And we have another talk here presented by Lumír Balhar, who organizes Pivo in Ostrava and teaches PyLadies in Ostrava and does many other things in Ostrava. And a person who signed up for too many roles. Right, take it away.
Thank you for introduction. Is it working? Yeah, right now. Okay, thank you. The keynote will have two parts. First, mine about how I started as a firefighter, how I started as a Python teacher, and what these two things have in common, which will be, I think, interesting. So, I'm quite nervous, so sorry if I will do some dramatic breaks. So I became a fireman when I was just 6 years old. And on the early beginning, it was just like, sport like everyone else, and the perfect opportunity how to meet new friends, and also a perfect opportunity how to go to fire trucks every time I wanted. So who doesn't want to do it, right? But after 10 years, when I was 16, it was the first time when I go to firefighters event, when I go to my first car accident. It happened like, 16 years old guy, just have nothing to do in firefighter station, and now the event come. Alarm sounded. I just want to help, so I opened garage to truck to come out. I just started firefighter's lights. Firefighter's lights, unplugged the power supply and air supply from truck, and everything like that. And I was quite nervous because every time when alarm sounded, it's like, ooh, something's happening. And this one event was special because commander came and read the report of car accident and said, okay, Lumir, it's time. Dress up and go with us. He's like, oh, really? I'm 60. Oh, shut up, dress up, you have 3 minutes. Okay. Fun fact about this, that this was a car accident with 3 silver cars, and just 10 minutes before this ended, somebody in radio told that statistics says that silver cars has a less probability to be in car accident. So I have 3 silver cars in first one. And it was nothing big, just, 3 silver cars in one accident. And only one injury is broken hand. But still, it was, really interesting experience for me, and I discovered the amazing feeling that will come when you help someone. And it was like, oh, I'm here, and now this lady have a broken hand, and this 3 cars is completely destroyed, and I'm helping. It's really, really good. So I decided that I really want to be part of this. And I joined the firefighters unit, because I really wanted to continue. And this is, I think, my first photo when I was in firefighter unit. It's not that hard to find me because I already had the long hair. I'm somewhere on the left bottom side of the photo. I'm not proud. Oh. So I just really want to be part of the group of people, volunteer firefighters, which helps people in the free time for free, just for the feeling, just for, knowing that you do something right. And the next years followed the expected course, so I became more and more experienced firefighter, but it was just not enough. Now I am in a unit for 12 years, almost 12 years, and it's not enough just going to events, car accidents, flames, injuries and stuff around. So, and as a volunteer firefighter, to be honest, you have a lot of time to think about stuff. And I had a lot of time to think about stuff. Now I haven't because I'm working for Red Hat. So the thing I was thinking about was, how can I help people before they need me? It's like, okay, it's perfect to save somebody's life. It's perfect to fix some car accident, etc., etc. But how can I help before they need me? And the older fireman taught me one golden rule. The better the prevention is, the less work we have. It's perfect, okay? I have a lot of experience about firefighting and stuff around, and now, okay, if I improve the prevention, yeah, I will have less work. It will be more boring times in firefighting station, but still, less people will be deaf. So, okay, I joined the program called HASIK. This program is focused on teaching prevention and stuff around firefighting to small kids. You try to explain how to do and what to do in case of fire, in case of car accident, in case of anything you can imagine, to 6 or 7 years old kids. And it's sometimes it's fun because, as you can see on pictures, in this situation we want to prepare the small kid when he or she met the firefighter, and don't be scared. And it's like this, okay, I start in the civil clothes, and then I just changing one part to another, and at the end, I am the complete firefighter with a breathing machine, with a mask, etc., etc., etc. And instead of scare, it's for every single kid, it's, oh, you sound like a Darth Vader. And yeah, it's awesome feeling. It's completely perfect when you save somebody's life. But when you know that you teach small kids something that can save others' life, it's awesome. It's perfect. And the more perfect thing is when you go to event where you need help from people around, and you see kids doing exactly what you taught this kid, instead of being in panic and yelling and running around. And the fun thing is that kid is perfectly without stress, without anything, doing exactly what you taught to this kid. And on the other side of the road is his or her mother and yelling and in panic and collapsing and everything is bad and we die here. Dramatic pause. Yeah, and then during the teaching in the HASIK program, I discovered another incredible feeling, the one when you use something you know to help others. So at the beginning, I wasn't planned to be some kind of teacher or something like that, but after years, I have a lot of experience as a firefighter. I know how to react when I see a building in flames, what to do during car accidents, etc., etc. But now I can use my experience and my skill to teach somebody something which may save their lives or lives of other people or family or stuff like that. Yeah, as they say, give a man a fish and you will feed him for one day. Teach men how to fish and you will feed them for a whole life. So, what else I know? The question was, now I'm pretty sure. But the question was, what else I know? And the answer was Python. Maybe. But yeah, I was quite experienced Python developer. And another question appears. Okay, is there any way how can I use my knowledge of Python to help people, to improve people's lives, to save careers, to help with study, to just simply the world around? Yeah, is it? It was, and it is. So I started as an organizer of Pivo meetups in Ostrava. Who doesn't know the Pivo? Pivo is meetups of Python developers or people around Python in Czech Republic. And I started as an organizer in the background, like, I'm not here. And after that, okay, maybe I want to say something about things I know in Python. So I started with short presentations and talking and teaching people around something I know well. Then I became chief teacher lecturer in PyLadies courses in Ostrava. So again, first I was quite stressed because I really have to know how to explain things to others, etc., etc. So it was quite hard in the beginning, but then the great feeling comes as in the situation I saved somebody's life. because great feeling everywhere if you do it. Yeah, this is the thing what firefighting and teaching Python have in common, because when you use something you know well to teach somebody and to help somebody, and not just saving lives or etc., but to improve life, to save a career, to find a better job with a higher income and stuff around, you will feel good. So, the question is, why should you do it too? First one, in teaching somebody something, is you will learn a lot new, and you will deeply understand things you already know. Because only when you have to find 5 ways how to describe one thing to person who cannot understand you, only in this situation you deeply understand anything. Because imagine the situation, okay, I know a lot of technologies, but if I have to describe this technology 5 ways, or even I know a lot of technologies about firefighting and I need to describe this stuff to 6-year-old kids, only in this situation you deeply understand what you are talking about. And trust me, I'm teacher at a college, and when you ask, okay, is everything clear? Do you want to ask for something? Everybody is, oh, don't look on his eyes, don't look on his eyes. But when you say the same sentence on elementary, it's like, oh, here, I want to ask something, I want to ask you, please, Mr. Firefighter, did you create a fire? Okay, I did. I had to. But how to explain to 6-year-old kids? Because otherwise it will go, to shop and burn a forest. You will meet a lot of new people with same interest, or you can make new people to be interested in the same thing as you. And if you love coding, if you love Python, if you love anything around, you will love to make people to be interested in the same thing as you. Also, you can help to improve or save job, career, life, as you wish. You will feel great, trust me. Really, trust me, you will feel great when you do it. And it's healthy addictive. So it means that when you will do it, when you will teach somebody something around Python, about anything you do or anything you know, somebody around you will start to do the same. And then we will be one big community sharing the knowledge. And that's my part of keynote. Thank you very much. And I'm giving the...
Okay. It's my part now, if you can hear me. Can you hear me? I think you can. Is it on? Okay. So I am not a firefighter. I'm just a boring programmer. I've been programming my whole life. I started when I was about 6 years old with QBasic. I went through a few languages after that, Basic and C. I made a Visual Basic detour. C++, I made my first money programming using C++. And then at the university, I found Python, and it kind of stuck with me. I was supposed to learn stuff like MATLAB after that, but I just used Python instead. At the university, I also had a Python course for the people who didn't know Python, which was pretty horrible. I didn't know what I was doing, but still a few people thanked me for it. So yeah, made some impact. Also at the university, I started going to Python meetups, which just started up in Brno, and so that there are other people doing what I like to do and like talking about it, and that was fine. We were starting a community. Then I made my thesis, which was a graphical game in Python, which is why I like games in Python, I guess now. After the university, I tried looking for a job. I didn't think I could get a job doing Python, but I found a company called Red Hat, and I've stayed with them ever since. And they kind of let me do all the stuff I'm doing now, so I'm grateful to them. Just when I started, I went to my first big conference, to RuPi 2012. Has anybody been at RuPi? Oh, I'm an old-timer now. So yeah, there was a conference, there was the meetups, and at the conference, or before the conference, there was something like we have Django Girls today. There was a Rails Girls and PyLadies workshop, like build your first web app in either Rails or Django, because Django Girls weren't around back then. I thought that was a neat idea. I didn't sign up for it, but I talked about it a bit with Lynn, the lady in pink over there, who's the founder of PyLadies San Francisco, and she was in Brno for a few months, and she really wanted to start a PyLadies chapter in Czech Republic. Now, what PyLadies do over the world is just meetups for women who like programming, but there weren't enough women who programmed in Python and wanted to meet others who were doing the same. So that idea didn't kind of work out, and she left a bunch of stickers that nobody wanted, basically. But a bit after that, on the Facebook page for our Python community, came 3 girls who wanted tutoring for their Python course at school. And they wanted to pay the tutor, which was really weird for us. I mean, there are these girls who want to interact with us, and and they want to pay for that? It just didn't make sense to us. These are actual reactions. I'm sorry if it offends someone. That's 2013. Maybe it's better now, but well. There were also other more sane reactions, like, we're trying to start PyLadies here. We're trying to find a way to make workshops, and here are people who want to come. This is perfect. We don't have to search for them. So we exchanged a few emails and started a tutoring group. It turns out their school course they wanted help with was made for computer science students, and they used examples like this for motivation. And the girls were studying library science or library studies, and this didn't really motivate them. And the course was, I mean, this is very interesting to me. But there are people who aren't interested in this. So they weren't very motivated to study that course, and most of them just wanted enough information to pass the exams, which, well, I signed up for tutoring, so I provided that information. But after the exams, a few of them stayed and said, we want to learn something more. So after about 6 tutoring sessions, we had about 25 meetups, about 6 months of weekly meetups, where I just came and told them something about Python. We made a project together, explained how something works, like HTTP or stuff like that. We made a lot of games, like a web page game, and we made some data analysis, a text game, a graphical game. There were a lot of games. Actually, games are a good thing to motivate people with, because some people like puzzles, some people like data analysis, some people just want to make a machine do what they want, but almost everybody likes to write games, which is was a nice insight. Kind of around the end of the 6 months, the school holidays started and attendance dropped, and one of the few people remaining was a teacher who convinced me that I should turn this into a real course for beginners. So I said, okay, I don't know if I can teach, but if you're telling me I can do it, then let's do it. So we made a plan of what I wanted to teach people. I didn't have a time schedule for it. It was open-ended. We'll end when it's no longer interesting for anyone. So we made an interesting course that was about 12 lessons. We had helpers in the room to assist with individual problems, so there could be more people in the room. And Radagoli volunteered for tutoring, so there was another session for people who didn't get something at the lesson or couldn't make it to the lesson for some reason, which wasn't used that much, but sometimes it was a big help. So what I did different for this course was I wrote everything I told them down. I usually do that for all my presentations, like I try to write down word for word what I'm trying to say, just to make it easy to see how much time it'll take. I hope I have enough time here. And to organize my thoughts. But here I put it into HTML. I didn't know too much about the web at that point, so I just wrote straight HTML and copied the headers and footers everywhere. It was pretty bad, but the text was there. That's what counted. And doing open source, I just put that on GitHub for everybody to read, which was nice because people who missed a lesson could just work it out on their own. People who didn't catch something at the lesson could, after the lesson, read it, or people from home who had nothing to do with the course could just read it and go through it. Or theoretically, someone could take these pages and organize their own course, which is what happened. Honza Kral was kind of jealous of these courses in Brno, and he wanted to start them in Prague as well. And he was looking for organizers. Then he found some, these courses started in Prague as well. They have a great organization team. They reuse the materials. And since it was more people organizing and interested in that, they had time for proper signups and all the administration work. They moved to Facebook instead of my preferred email. Whatever works. Yeah, so now it kind of grew like that. It wasn't just me teaching some people. It was a movement. Yeah, it's interesting when I started here. They made a web page. See, it has a giant picture that's just there to be pretty. You can tell I didn't design that. It uses an actual web framework. So yeah, this was pretty successful. After that, Lumir heard about it, and he started the same thing in Ostrava. So now we had about 13 courses in 3 cities. It grew out of control. And also some other people took a note about this and told me, hey, you're doing courses just for women, and isn't that discrimination? You're leaving out half of the population. Yeah, that's true. It is discrimination, isn't it? You know what's also discrimination? The courses are in Czech. I'm leaving out 99.9% of the population there. Well, some people actually emailed me, I wanted an English version of this. Why won't you teach me in English? Well, my standard answer is there are materials to learn Python in English, and they're pretty nice. So those English speakers are pretty much covered, I guess. And I didn't want to compete with Coursera, and translation isn't really my thing. So yeah, what I do is courses in Czech. Sorry. Actually, there's more discrimination. The course I can do is about for 20 people per semester. This leaves out 100% of the population, right? So yeah, it's pretty bad. Not everybody can be there, but I guess So what am I trying to say? Yeah, I guess it comes down to how I want to spend my evenings, right? I teach somebody in my free time, so who do I pick to teach? If you think PyLadies was a radically feminist idea, maybe. Yeah, there's a lot more stereotypes in these beginner courses than it might seem. Because, well, okay, I want to be clear here that I'm talking about the beginner's course for PyLadies, not about the organization itself. So just for the part that's a kind of I'm involved in. But when you design a course, you want to know who you're designing it for. You want the whole class to be at the same level. You want to know that level so you can tell them things that they'll understand and that they'll understand. So my persona was a complete beginner who doesn't know anything about tech but is motivated to learn, and that is stereotypically a female. Right, so yeah, that's that. Also, another stereotype, women are shy. If you do a course for everybody, you'll get 19 guys and 1 girl. If you do a course for just women, you'll get 19 women and a guy who says, well, there's one thing I don't really fit in, but why not sign up? And stereotypes are mostly statistics, so yeah, it does work in practice. And universities and stuff are full of programming courses for everyone, so why not give the girls a little extra motivation, because it's lonely without them. You probably noticed a trend of people and companies getting more women into IT. And maybe you ask the questions, why are women so special? And it turns out they're not that special. They're just an easy first target. So what we want to do here is change the situation where you have teams where everybody's the same and everybody's afraid to step out of line. Right? If you have a team where everybody's the same, it's hard for someone different to join. It's hard unconsciously for the one who's hiring, and it's also hard to ask for that job by the person who's coming, right? So if we try to get more shy people, or if we try to get more women, we remove kind of this barrier of trying to fit in. We get a little more diversity. Oh, I said the word diversity in Czech Republic. Yeah, just a tiny bit more. We make it a tiny bit more normal to be different. And that makes it easier for more different people to come. So then you have teams that are all different, and it becomes harder to think, this person is weird, even subconsciously, and having that influence your decision, right? As who hires people. And it also makes it easier to come to the team. And then you're not missing out on the good programmers that happen to wear a skirt or happen to be shy or whatever, right? So it's a tool to get more of the population into the teams. Yeah, so that's kind of what I think about this diversity thing. If you don't agree, I don't really care. See, it makes sense to me. So I help PyLadies. If something else makes sense to you, you're perfectly free to help anyone you want, right? You can help a group of alpha males. You can help a group of miners from Ostrava. You can go help homeless people. You can go help left-handed Inuits, or make a course for everybody. I mean, if you see somebody dragging in a direction you don't agree in, try to drag in a good direction instead of pushing against. Right? And also, if you want any help organizing a course of any kind, please talk to me or anybody who organizes these courses. We'll be very happy to help you. It's not trivial to make a course, but it's definitely doable. It does take some time and a dedication. But if you want the know-how, if you want the materials, we'll be very happy to help in any way we can. Right. So I've been arguing for PyLadies a lot, but turns out I'm actually not a PyLady. You can tell by the beard. I'm glad that won't be on the recording. So yeah, I bootstrapped the organization, but now they're doing pretty well on their own. They have organization teams, even in Brno, where everybody just thinks I'm the main contact person. I'm not. But if you don't know who to contact, then I guess I'm the best. So I just act as a mentor. I'm a mentor at the PyLadies Beginners course. That's my relationship with that organization. And so I teach courses for them, and in return, they may help me make sure that the materials I write for the courses stay relevant and stay understandable, which is really good. You know, if you write some tutorial, you really want live feedback for it. Otherwise, you really don't know how people react to it. And since there are PyLadies, I don't have to organize anything. I don't have to go and find venues and communicate with people on Facebook and stuff like that. I just get to, in the ideal situation, I just get to focus on the teaching and the creation of the materials. And that leaves me free to do other things. So last semester with Miro, we organized a course for university students at ČVUT here in Prague. It was a very different experience. Instead of an informal course, we had something that was graded, and also the people weren't really beginners. They were hopefully more competent programmers. Miro was laughing. Yeah, it's hard to learn this, and even at the university, it's not that easy, especially if you drink a lot instead of studying. But we did use some lessons that I learned at the beginners courses at PyLadies. So the main lessons are: write down everything that should be said. Right? Everything that's in the course should be on the webpage that you're preparing for. This is good for people who had a problem at the lesson and need to catch up. This is good for people who missed the lesson for some family reasons or anything. This is good for people at home who just want to study and that they don't fit in your target group. They're not a student at the university, they're not a woman or something like that. And it also helps other organizers. So if your stuff is good, other people can take it and run with it on their own. If you make it open source, of course. That's number 2. Put it in Git, put it on GitHub or GitLab or whatever. Invite collaboration for other mentors, even for the students themselves. Make it easy to make the materials even better than they are in the spirit of open source. I guess most of you know how that works. And then you need to teach. Right? As I said, for the course to stay relevant, you need to get continuous feedback from live people. It's kind of like code. If you write code but never run it, there are probably bugs in it. But if you test it, you will get a chance to make it better and better. Also, this duality between these materials is usable either online from home or offline face-to-face is good for portability. So you can transfer this to other mentors, and they'll be able, hopefully, to take it and teach it to other people. Because I can only teach 20 people a semester, so I do need some help. Right, so now we had 2 courses written down in this fashion. So I wanted to consolidate them into one place, and so we got a domain from the Python CZ guys. It's called nauczce Python CZ. Currently, it's just a collection of everything that me and Miro wrote down, or well, me, Miro, and other collaborators. So we did get some contributions, but I want to make it into something more, into something where you can branch your course from that. So if you don't like a detail, you can make a branch, make it work for you, and then make a request like you would on GitHub if it fits relevant to everybody. It would also be good to put stuff like homework problems and everything like that there. Work on it is it's slow. It's a side project, but it'll eventually get there. So watch that space. It looks really horrible. If you have design skills and you're willing to share, then we could really use you. But if you want to learn Python, or if you want to teach Python to somebody, we have a beginner's course, and we have a course of the essential Python libraries, so you can see those there. So now you know where to get the stuff to teach. Why should you teach? As Lumir said, teaching gives you this great feeling of helping somebody. I can't explain that. You just need to experience it. It's really good. Try it. But it also makes you a better programmer. Why is that? Because through teaching, you come to understand people that know less than you. You come to understand what they're struggling with, what the problematic parts are, what the confusing parts are in libraries that you're using, in the language itself, what needs to be explained more clearly, what they won't get at all. And this helps you write more maintainable code. Because what is maintainable code? It's code that can be maintained by as many people as possible. And chances are, at least in some areas, very many people know less than you. Right? So if you understand how to explain things to them, how to name your functions and variables, like how to, like what comments to put in the code, if you learn to reference things that you think everybody should know, like this uses recursion. Here's the link to Wikipedia. You can read about recursion as an example. That's really helpful for beginners. So that will make your code more maintainable, which I guess is something we're all striving for, hopefully, unless you want job security. I don't know why. Right, so so you understand people who know less than you. Also, it turns out in other areas, other people know more than you. There's always something you can learn from a person. So you also get some information out of it. Maybe you learn something about programming from another tutor. Maybe you learn something about something completely different from the attendee. It's really good as dedicated knowledge transfer. Right, so do teach. If you think you can't do that, well, I think you can. Just join as a side coach, as somebody who's not doing the explaining, but helping with individual problems. We actually tell the graduates of the beginner's course that they should come next semester to help coach, which is really helpful. It makes them repeat what they learned, so they get a more solid knowledge. It helps them see how far they've come. Like explaining to someone that you can press the up arrow on your keyboard to get to the last command on the console is something they learn in I don't know, a month at most. But when they finish the entire course, they feel like they're really at the beginning and they don't know anything. So coaching helps them, see what they actually learned and what other people don't know. And of course, it helps build a community, and it helps us because when there are the beginner questions, we don't have to spend time on them, and we can help more people at the same time. So if they can do it, so can you. So try to get in touch with some of the organizers. Come to a lesson and try coaching. Maybe you'll like it a lot and branch off your own course even. Right, so that was my call to action. Here's another one. If you want to hack on Nauč se Python CZ, we'll have a sprint on Saturday. I will try to make it beginner-friendly. I will try to have some very hard tasks there if you'd like. So come say hi. And if you have any questions for me or for Lumir, who should be on the stage somewhere, then fire away. Ooh. Okay. So I signed up for too many roles, and I'm also the moderator, so I will read the questions for myself. How many of these PyLadies are now employed as developers from those courses? Unfortunately, because I started just doing the minimum I could of organization to get people there and for me to teach them, I didn't keep any track of the ladies I was actually teaching. And I have a very bad memory for people. So I really don't know, and I hope this is something the current organizers will improve, so we can have a bit more statistics. But one former student at the beginners course is now doing an internship in my team. I know of about 3-4 people in Red Hat. Do you want to say something? Yes, yes. Give the mic to Veronica.
Hi, can you hear me? My name is Veronica. I am... Už?
Can you...
Mě neslyšíte.
There it is.
Hi, my name is Veronica. I am a PyLadies organizer in Prague. I have numbers for Prague, so I can answer this. It's now, after 2 years of those courses in Prague, it's over 35 girls.
Thanks, Veronica.
Alrighty. So how much does a Python developer earn compared to other programming language developers? That depends a lot on how much do you know, what kind of Python developer you are. I honestly got hired or looked for work in Python instead of Java or something because I wanted to get Python and not because there was more money in it. But it's enough. And that's enough. Is there also a Pivo meetup in Prague? Yes, yes, there is. If you don't know about Pivo meetups, you should definitely go to Pivo with a Y, pivo.cz. And there's a schedule of the tentative dates in case the meetup is not announced in advance, which it sometimes isn't. So go there. It's every third Wednesday of the month. Okay? So can we offer job to those attendees from courses? Yes, I believe there is a way. I'm sorry, I'm not the organizer. I just teach, and I try to stay away from the organization. Yeah, Veronica has details, I think.
Yeah, just ping organizers. Yeah.
Sorry, Veronica, for directing more people to you.
Of course, you can offer the job for attendees or graduates from PyLadies. Just ping the organizers. Depends on Ostrava, Brno, Prague, situation. We can promote you at the beginning of the course, everything.
But there is one thing I have to warn you. The beginner's course makes you a Python beginner. It doesn't make a junior developer, right? So you can hire hire an intern and teach them, you have a pretty high chance that they're motivated to study more, but they won't really know enough to be a junior. All right, we're almost out of time. Do you see any differences in how the ladies think, approach computer science compared to guys? I haven't taught enough guys. Yeah, somebody should do a comparative study, which will, I guess, be more statistics and stereotypes. Yeah, I don't know. Sorry. So, are you planning a kind of course for kids? There are so many plans. I can't do it all. But if you want to help, please talk to me, and I'll give you lots of tasks. And if you want there to be a kind of course for kids, I can tell you what to do so you can make it happen. Typical open source answer, right? Patch is welcome. Do you or other mentors organize advanced courses for PyLadies? Yes, other mentors do. Lumir has some advanced courses in Ostrava. There's PyWorking in Prague. So yes, I think these courses are not really limited to women, though.
No, it's not. And in Ostrava, it's based not on written materials, but it's based on the project. So every graduate from PyLadies can come with project, and we will be there and help with troubles, issues, and solve the problems and move the PyLadies forward to solutions. So yeah, Advanced PyLadies is here in Prague, in Ostrava, in Brno. And it's not limited only to ladies.
Right. I think we're hopelessly out of time now. So thank you for enduring this, and see you at next talk. Right. Sorry for the delay. It's my fault entirely. Please welcome Miro Hrončok, a Python developer and Fedora packager, who will try to mock you.
Thank you. Hello everybody. My name is Miro, and I work for Red Hat, and I do a lot of Python. I guess you're here, so you probably do a lot of Python too, or you at least want to. And when I code in Python, I usually do one thing. I put everything to GitHub and open it publicly, make it open source, because I think that open source is better than anything else when it comes to code and content as well. And having the code on GitHub brings me wonderful things. People are sending me pull requests, or they are not, because they are not interested, but that's not fair, sorry. What I can do is use some services that help my workflows. And one service I very much like is Travis CI. If you don't know that, Google it up. It's a continuous integration service. And it's awesome because it runs my test automatically every time I push or every time somebody makes a pull request. What's a bit sad about it is if you want to have your tests being run every time, you actually need some tests. And we probably all know that tests are great. They are good, and we should write them, and we should write them first. And test without code without tests is buggy. We all know those kind of things, but at the end, we say, I don't have time for writing tests. Writing tests is too difficult. This code is too complicated. I won't write tests. It's, let's go and have a beer instead, or something like that. And then if you don't write tests and you want to learn something about tests, you usually find some examples on the web. And those examples pretend your code is pretend this is a piece of code. It can be a function, it can be a module, it can be a package, it can be a box, it can be a cat that's either dead or alive, stuff like that. And usually you have some input, you have some output, and if you test your code like this, you put something in, you see what's going out of that. And if it's what you expected, then your tests are green, everything is great. If it's something you didn't expect, then something is wrong. Either the test is wrong, or your code is wrong, or the weather in North America is wrong at that point. This is a simple example of such tests. There is I think it's a kid's game called FizzBuzz. So you say numbers like 1, 2, and so on. But if their number is divisible by 3, you say fizz instead. And if it's divisible by 5, you say buzz instead. And if it's both, you say FizzBuzz. And writing a code for this is simple. It's 2 ifs or 3 ifs and stuff like that. And writing tests for this kind of code, that's easy as well. It's absolutely classical academical example. You have a function and you put something in. On the first test, we put the number 3 in, and we assert that it has some output. Writing tests for those functions is easy, simple, and probably everybody can do that. In reality, our functions look like this. And it doesn't have one input, one output. Look what it got. It has everything. So it has some inputs, then it has a hook to the database, then it has a magical vortex that spins around and swirls, and that may or may not interfere with your function or with your package or whatever. There is probably an API that your code is using and stuff like that. And when it comes to this, people say, the tests are really, really hard to write. And what shall we do? Well, you have basically 2 options. Either you don't write stuff like this, but yeah, we know our people. So you can don't test it, or you can mock it, cheat it, remove the vortex, replace it with some fake vortex, remove the database, replace it with SQLite, or even a dictionary or something like that. When your code touches arbitrary files on your computer, such as this one, you can't really test it on other machine than yours. If it uses a production database, and you want to run your tests on production database, you are being crazy. So you need a copy of the database and stuff like that. And especially in cases when something that is not under your control can interfere with your code, usually you say, let's mock it. Or you say, let's something else it, and you don't write your tests. When it comes to mocking, usually there is a little bit of confusion because there is a big thing called mocking that includes various kind of mocking, and one of those things is mocking. That's kind of big confusion with names, so let's call it cheating. And when I say cheating, it's not necessarily something that's wrong. Cheating is great. If you cheat when you program and you get the good results, you're actually a better programmer, I guess. But it's not something they will teach you on the university, though. When you use cheating to write your tests, it's still a little dangerous. It's not dangerous like somebody sees you cheating and says you should not cheat, we fire you, or something like that. But if you over-cheat your tests, you can end up in hell, or your project, at least. There are several ways of cheating. I decided to talk about those 4: fakes, stubs, mocks, and spies. Usually when you have a mocking library, or a cheating library, in fact, usually called a mocking library, it offers several of those. Maybe sometimes it offers more, but usually it offers those 4. Let's go over those 4 a little bit. I will try to explain what they do, why they are good, what they are good for, why they are bad, what they are bad for, and when you should never use them at all. Let's have an imaginary vortex class. That's the picture before. And it can swirl. We don't really know what it does. It may be dangerous. It may, or your computer, or all your money from your bank account. And it returns a thing that looks kind of like vortex. And then it has a double swirl, which is just an example that you return one swirl plus another swirl. Is this code understandable? OK. So let's have a fake. Imagine you need the double swirl is not there. Vortex is some library you don't own. It's a very famous library. Everybody does pip install Vortex to have vortexes. And you have a function that's called swirl twice. It's your function. And it expects you give it a vortex. And it calls swirl and swirl. Now, if you write your tests and you just use the general vortex library in your tests, it will destroy the word twice. And at the end, your test will never finish because there is no more universe. So you need to fake the actual vortex. And this is, of course, funny and imaginary, but it can be something that, I don't know, uses a real API, does something that's not available on the system the tests are being run on, and stuff like that. So you create a fake vortex, or fake something. Here is the class on the top, fake vortex. And you redefine the swirl method just to increase the counter. And then if you create the fake vortex and give your function the fake vortex, you can test if it was called twice without actually calling the vortex itself. So I have some examples in here. Let's try, better go with this. Fake. There is some test that passes. It's the very test that was on the slide. Actually, I have mylib.py that has this function. It takes a vortex, swirls, and swirls. I also have the better library that has the original vortex thing. And if I remove the library, I can run the tests, and they are still passing. That makes sense. I am not using the library at all. So if you are using fakes, always only use them if you're not trying to test the thing you are faking. Because at the end, if you test the faked thing, you can as well delete the test and just grab a beer instead, because you are testing an imaginary code that's fake. I have another demo for fakes, and it's an unfortunate situation that, what do I have here? The library is created like this, the code you're testing. You don't have a swirl twice that takes a vertex, because you don't really care. You have a function that creates a vertex, swirls it, and returns it, because you need double swirled vertexes all the time. And now you can't really put there some arbitrary vertex, and you could say, let's mock it. But instead, you could change your API to use dependency injection and have an optional argument that takes a vertex and only create a new one if you didn't give it another one. I am slower than I expected, so no demo this time. You just have to trust me. Then there are stubs, which is you take a real vertex this time, and you redefine part of it. So let's say we have a real vertex, but what's dangerous or it takes time or whatever is the swirl method. So let's replace it with our lambda that will just return a swirl symbol. That's a swirl symbol if you didn't know. And now we call the double swirl, and we are ensuring it's returning two of those things. So I have the test in here. And the test passes, and it never actually calls the library inside the swirl function, but it calls the class. The problem is, if I change this return statement to this to something else, and I run it again, it's passing. So you have to be careful what your test is actually testing. In this case, it's testing the only thing. If the double swirl is called, it returns twice the thing that we gave it as a swirl. Or it returns those exact symbols. Then you can parameterize it to check if it's not the case. You can say stops are not enough, and you need an actual mock. An actual mock does two things. It changes what a function or method or callable does, and it instead gives you a return value or an exception or something like that. And it also records how many times it was called, maybe with what arguments, and stuff like that. So in this code, we replace the swirl thing with a mock. And the difference between a stub is now that we can actually say as call count 2, and we assure that it was called twice. Now this is good if you actually need a test that says test that double swirl calls swirl twice, then it's useful to check it, and also sometimes useful to replace what it does. If you don't want to replace it, you can use a spy, which behaves the same way, but it doesn't actually change the value. Let's see the difference. So I have test mock and test spy. They are both passing. Now, if I change this to plus, and I'm breaking spiral, but I'm keeping double spiral intact, and I use the mock, it passed because I changed the spiral method. But if I use the spy, it dumps me some things, which is the side effect of spiral, better than if the room explodes, right? And at the top of it, it actually says, yeah, the output was not what you expected. On the other hand, if I change this and make it correct again, but I cheat this, and I simply return it twice. Now, if I use the spy, it will fail once I check the call count. The same thing, of course, happens with the mock, because I'm checking it in both places. So let's have a summary in here. I have 10 minutes. If it's a dependency, you don't need to check or test. If you trust it will always work, or the upstream of that library has different tests and stuff like that, and it is hard to use the original library, fake it. Fake the library, use a fake. If you can't fake it, because your code cannot accept fakes, because it creates the thing from the library, extend your API of your functions, of your modules, so they can use custom dependencies. This is the thing when we added an optional attribute for a Vortex. This actually makes your code better, because then might be a better Vortex library in next 10 years, and you don't need to change your code, but somebody who is calling it can just put there the better Vortex, even if you don't really care and you created it 10 years ago when vortexes were really bad at that time. If you need custom results, so if you really need that some function should return something else that it normally does, you stub it, or you stub the class, or you stub the module, you partially replace the function. So for example, you can stub a random call, so because you need to check in your algorithm that starts with generating some random number that at some point the result looks like this. But if you actually use random in your code, it's hard to check. So you can stop the random module to return the arbitrary values that you say. So you can have a random generator that always returns 4, and you swear it's random. If you want to actually test whether something was called by a function, which you sometimes don't really need to know, sometimes you do, you spy it, and only use a real mock if you need it all. If you need to change what it does and count how many times it was done, which is, if you think about it, not that common, but people tend to use mock all the time because it's the first thing they find. Be very, very careful about what you actually test. Sometimes it can be that you are testing the fakes, the stubs, and the different code that you intended. We had a project that has like 500 tests for everything, and it was like, if you send a commit, you need to write a test for it. But the code was so complicated that we mocked everything in the tests because we couldn't test it otherwise. And once we realized the program won't even start, but all the tests are green. So a good way to check, it's not 100% sure, but it is a good indicator. If you remove the implementation and the test is still green, you're testing something else. Don't overmock. Don't use mock when you don't really need to. I have another demo. It's going to be a short one. So there was an example of ATC password file. So I have something in here. It's a simple code. You don't need to read it all. What's important is here, it opens ATC password, which stores information about users on Linux and Unixes, and it returns a dictionary. it parses it. Now, if I import this and call it, it works. Ta-da, I don't need no tests, right? But if I want to test it, I might say, what system is this being run on? I don't know. I could test if root user is there, but there might be some weird Unix that doesn't have root, or I don't know. So that doesn't work. So what do I have? Test with mock. So I mock it. I change built-ins open to return a string IO instead of the open file, and I call my thing with mocked open, and I hope everything works. What's the problem? Is that then I go to a conference and somebody has a talk about pathlib, and I say, yeah, pathlib is so cool. Let's change my code to use pathlib. And a very simple code change that doesn't change the API and the behavior of the function at all will completely destroy my tests. Because now I am patching open, not path open, but open. I need to change this import. And it's failing because it still returns the stuff I have on my system and not the stuff that I mocked. And now I have to think where I am mocking this thing. And should I, when I test the internals of my implementation, I need to change my mock as well. Instead, in this situation, I shall not mock at all because it's so easy to avoid it. All I need to do here is to change the API of my function to accept the path instead of hard coding it inside. And now I can use it with default etc passes over there. The function works as it did before. But here, all I need to do is create a new file, put the content in the file, and give it another path. And now if I change the implementation, even if I use open, even if I use pathlib, it doesn't really matter because I didn't use mock. I just made the API of my function a little bit different. One could say better, because now if you have a weird Unix that doesn't have this path but a different one, you can still use it. And I made the testing much more simple. What's important is that you don't forget that practicality beats purity. So even if I say don't mock, you should mock if it works for you. And it always is a better thing to mock, mock, and mock than to not test at all. Just be careful that you are not testing your mocks instead of your code. And that's all. Thank you.
Thank you, Miro. And we do have some questions over at Slido. So what mocking library would you recommend for Python?
None at all. You can create all the stuff you need just with your actual code. So I have, let me see. That's Vortex, test with spy. This is a spy. I created it because it was faster than searching a library that does have a spy. It's easy. But really, if you want to use a library, I like to use FlexMock, but it has a very Ruby-ish API. But it's easy to use and easy to remember how to use. But it is kind of very easy to overmock with that. So be careful much more than anything. There is a mock in unit test, which has some functions. It probably doesn't have spies, though, and FlexMock does.
Thanks. This is a terminology question. Why do you use cheating when you can use the term test doubles that has been established by Martin Fowler and is widely accepted by the community?
because I didn't know.
Thanks for admitting that. And what tooling do you use for your demos? What's the next command?
Can I get it back? It's an alias for git reset if I do changes and clear. That's cool. That's not tooling. I just realized when I was testing this presentation that writing git reset hard and clear all the time makes typos and stuff, so I created next. Next.
And that's it from Slido. Do we have any more questions here? Any brave soul? Nope. Okay, thank you, Miro.
Thank you.
Hello, hello. Hello, hello. Hello, hello. Hello, hello, hello. Can you hear me? No, can you hear me? You can hear me.
Right, welcome back. I think there's still lightning talk signups and some workshops, so register if you want. And please welcome Evgeny, Kubernetes automation engineer at SUSE, and an active open source contributor who will tell us something about Splinter. There we go. Evgeny.
Yeah. Hi, guys. How it's going? Okay. So yeah, I will talk a little bit about how can you guys test the web application with the Python framework called Splinter. So yeah, first slide about me. I'm Evgeny. I work in Prague for SUSE for 2 years now, but I'm originally from Russia. You probably can hear it with my Russian accent. I'm a senior automation engineer at SUSE in Kubernetes team, specializing in Linux, OpenStack, and containers. And also I am Docker Prague meetup organizer here in Prague. So what this is all about? It's about testing the web apps, and if you're interested in this topic, then it's a really good talk for you. If not, so you can, feel free to grab some coffee and, relax. Yeah, let me begin with a small story. So 2 years ago, I came here to Czech Republic from Russia. I had curly hair. You maybe can't believe me now. Yeah, and words like was krasny život sounds really funny for me, because in Russian it means you have a red belly. And I was like, what? No. Yeah. Anyway, yeah, I started my career at SUSE as a QA maintenance engineer, and it was like real manual testing over and over again. I was the part of the OpenStack team, and we had a lot of web applications there, and we need to test it over and over again before update and after update, and it was kind of boring. Yeah, and the part of the SUSE OpenStack project, was the Crowbar, the web application that I wanted to test, needed to test. It helps us to deploy the SUSE cloud, and it looks something like that. So it's a huge web application. You can see like this, a lot of buttons and everything, and you can imagine that, you log in and you have to click everything, and then you should update this stuff, and then you should click everything again, so it was kind of boring. No. What's happening? Shit. Yeah, it's working. Yeah, at SUSE we have a thing called Hack Week. It's basically during 1 week, 2 times per year, you can do whatever you want, like related to software engineering, or maybe if you like to play the guitar, you can play the guitar whole week, and it's like interruption-free, and you can learn a lot. So for me, it was like really nice thing. I was thinking that, okay, from this week, I can automate this boring Crowbar testing. And yeah, and in my head, it was one idea that I wanted to use Python for that, because it's awesome, right? Yeah, and in the end of the project, I created the tool called Gordon, because, Crowbar, Gordon Freeman, Half-Life, anyone? Yeah, okay. So yeah, so basically it's script, you just run it, and the browser is open it, and then everything is automated, and it's pretty cool. You just need to run the script before and after update, and that's it. Yeah, and I used Splinter. Splinter is an open source tool for the testing web application using Python. You can read it here probably. And it sounds like Selenium, right? And you're kind of right, because Splinter is the abstraction layer of Selenium. And it makes easy to write automation tests for the web applications. So why use Splinter? It has a really simple API. Multi-web drivers, you can read it, Chrome, Firefox, Phantom.js, no Internet Explorer or Edge guys, sorry, Windows guys. Yeah, and CSS and XPath selectors, which is pretty cool. You can go, for example, if you are using Chrome, you can press Ctrl-Shift-C, you can go to developer mode on the web page, and you can, for example, copy some element as XPath selector and put it in your code. You can execute JavaScript, and yeah, works with Ajax and JavaScript. So, samples. You can see the codes in Selenium, and you can see the code in Splinter. Basically, if you want to fill the username field on the page. It's simple like this. Awesome. Yeah, and more. So on this example, I want to go to the webpage bing.com and found my Twitter. And step by step, yeah. First of all, we need to import browser and instantiate it. So yeah, from Splinter import browser, and with browser as browser. By the way, if you are not putting anything in the browser, on the last line, you will use automatically Firefox. But you can put there Chrome or what do you want? Yeah. Then we are visiting website using the browser.visit method, and fill the form. You should find this SB_form_Q with, as I said, Ctrl-Shift-C on the developer mode in the web page. Yeah, and put their Twitter account. Yeah, and then with methods find by ID, you can you can press the button and don't forget to quit. So it's just simple like it is. Yeah, here I found the really nice information. If you know the web page called pythonlibhunt.com, you can compare like frameworks or yeah, and we can see here Selenium versus Splinter, and this is code quality is pretty cool. You can see that with Selenium, the code quality is L2, and with Splinter is L5, and Selenium using the JavaScript and Splinter using Python, right? And L2 basically means that the source code is still low quality. However, there are places of the gems to be found. Projects feels more managed. However, refactoring should be at the top of the agenda to keep the project maintainable. Keep up the good work. And L5, like in a Splinter case, it's excellent work. You have built high quality, fine-tuned, and optimized machine. You should be proud of your achievement. So, yeah. Probably you can now you can think that you can do everything with Splinter, or you should throw away all your Selenium stuff. But my answer will be hell no. Because don't forget about the Dunning-Kruger effect. It's boring description from the Wikipedia, but basically it means that if you are starting with some technology, you feel like your superpower, yeah? You feel like, yeah, I can do everything with that. It's like, that's cool. So yeah, and in my case, it was the same. But we have a lack of advanced features in Splinter. So no screenshot functionality. For example, if you want to have a screenshot of some step on the web page, you can't do that. And no clicking-based test creation like you do with Selenium. So, but this list can be go on and on. And because I had these two issues, but maybe you have something else. And that's why I think that this project needs some help from you guys. So feel free to go to this website and check it out. Maybe you check out the simple code and you know, maybe add some features that you are missing, because this project is really cool. So yeah, review. Yeah, Splinter is cool. Splinter is simple and is fast in terms of development time, basically just because you are typing less than, yeah, Splinter. Yeah, but if you need to test a complex web application, you still should consider using some Selenium code in your project. Yeah, That was quite fast, I think, yeah. So useful links, this first one is docs, the Splinter docs, and the second one is the GitHub project. Yeah, that is pretty much it, I think, yeah. And I saved 10 minutes of your life. Yeah, thanks. Any questions?
Thank you. Do we have any questions? Questions, comments? Or
After
wow,
how
they're
many
coming.
attempts to breach
After how many attempts to breach, or which conditions do you consider a server as secure?
After how many attempts to breach? I'm not sure how to answer this question.
Is the asker in the room? I'm not sure I understand the relevance either. Okay. Sorry. Maybe if you find Evgeny afterwards, you can talk to him and
Yeah,
ask,
feel free to catch me. It's like
ask
I'm
a
in a
better
green
question.
hoodie.
All right.
Yeah.
Is it possible to mix Splinter and Selenium?
Yes, it is possible. In one code you can mix it because, as I said, Splinter is just abstraction layer. Can Splinter help me with captchas? No, I don't think so, that it can help you with captchas, but feel free to add this functionality to the code. As I said, the project's really cool, but it has not so many developers, not so much attention as the Selenium, so that will be pretty cool.
Thanks. Any more questions? Okay. Thank you, Evgeny.
Yeah, thanks. Thanks, guys.
Cinema Beats. This is a Cinema Beats production. This is a Cinema Beats production. This is a Cinema Beats production.
Tomorrow's production available on today's market. Upgrade your sounds today and start making hits.
Cinema Beats. This is a Cinema Beats production.
colors burn like the one you light within me. And these colors fade and wash into rays. Shaded turn, time slows and still waits. Watch colors fade and wash into rays.
All right. Hello, everyone. I think there's still some space for the lightning talks, so if you want to make me happy, sign up. There's also some tickets for workshops on Saturday. If you want to stay till Saturday, there'll be some fun workshops there. And now it's my pleasure to introduce Brad House, who's a longtime Pythonista, ex-Skyper, and he has a lot of experience with lots of interesting projects. And he'll be talking about REST service load testing. Welcome, Brad.
Thank you. So yeah, I've been working with Python since 1.5, I believe. That's when I first got into it. I actually worked with Tim Peters at Dragon Systems in Massachusetts. If you know who Tim is, you've probably seen some of the things he's written. And today I'm going to talk about REST service load testing. So for this company I'm working with, we have a cloud service running in Azure. It's actually running Mattermost server, a chat server written in Go. And our customer wanted to know how well it would perform under load. So I'm like, okay, well, I think it would do fine. I mean, but they wanted some actual numbers. So I thought, well, I could look into some tools, see what's out there. But I'm like, well, this can't be that hard to do. And I hadn't done any async I/O stuff. I hadn't actually really done too much Python 3 programming. Still stuck in the 2.7 world. But I gave it a shot. And actually, it came out pretty well. And I'm going to talk about some of the features that I used. I'm going to show code, but it shouldn't be too complicated. And I hope it actually illustrates how simple it can be to use the 3.5, 3.6 async I/O capabilities. So for testing, what are we trying to do? So we're going to try to simulate multiple users using this live chat cloud service. We're going to be performing a variety of GET and POST transactions over HTTPS. And all of these users are on their own. You know, they should be just as if we had people coming in and using the service. We don't want to be blocked, so we want to do as much concurrent processing as possible. And I'll talk about this in a little bit, but later in the talk. But we don't want to just, lockstep send request every, say, 0.5 seconds. We actually want to see how the system will perform as users come on and they start logging in. So this is kind of what's called a random, a stochastic random process, a Poisson process. And of course, we want to record the times that it takes to actually do these activities. So real quick, here's what we're going to be doing. We're going to be logging in. We're going to be fetching some stuff. This is all based on what Mattermost offers and what the client wanted for their users. So there's quite a bit of stuff that we're going to be doing. I'm not going to go through all of these. I'm just going to illustrate some common principles that we use to get these things to work. Now, the fundamental building blocks that we're using are it is 3.5 at least, because we want to use the async and the await expressions in Python code. We're using the async I/O module, because that gives us a run loop, although you could use another run loop as well if you wanted. And I'm relying on the AIO HTTP module that's separate from the Python base. And that gives us all the HTTP connectivity stuff, and it's all highly performant, and it's using asynchronous processing. Finally, there is actually a bit that I will show you I'm still using the multiprocessing library of Python. And the reason is that even though with asynchronous processing, we gain some concurrency, we are still, using one event loop. And if we have multiple users acting independently, that can cause some blockage. So we want to have all our users operating independently. We'll use multiprocessing to do that. Now, this is a really noisy slide, but basically it's just showing, for those who don't quite understand what async I/O does, you start with an event loop, And in this event loop, you have these tasks. And tasks can have one or more, essentially, futures or coroutines associated with them. And they will not make any further progress until the coroutine that they're dependent on finishes and gives them a response back or an error out. And so that's just basically what this is illustrating, that we can always make progress even if something else is waiting. That's the gist of async I/O. Now into some code. So first we're going to set up, I have a, by the way, this is only about 250 lines of code. It's in one file that does all of this processing. So it's very simple, although it may look a little odd. But anyway, I have a class called Mattermost that's going to be the test driver. It knows how to talk to the Mattermost server, and it's going to be issuing these requests and look at the responses. Again, I'm introducing a run loop. This is from the async I/O. And this client session here is actually from AIO HTTP, which provides me connection pooling. And again, it also knows how to do all the HTTP arbitration. Now, I need to do a login. That's the first thing I'm going to have to do as a user. And here we have a method in our Mattermost class that's tagged as async. So right off the bat, we have something new in Python. It's this, Python 3.5 and later. And it's basically saying that this method here, login, will return when you call it, but you actually don't know it's not going to do anything yet. It's going to wait until it gets into the event loop and look at what's inside and say, oh, I've got some more things to do. I can either, I need to wait for something to finish processing, or I can return to the caller. And I'll show you how that happens. But that's the first thing. We have this async tag. And within it, we actually have another async. We're saying, OK, we're going to set up the attributes for our REST call. And it's a post transaction. So I have a URL and all the stuff that I'm handing to the call. And I'm going to wait for that to happen. I'm going to wait for the response. So I can't make any further progress until that comes back. However, the rest of the code can do whatever it wants. The event loop is still running. Once I get a response back from the post transaction, I interrogate it to see if it succeeded or not. And then I also await here on the response, because maybe it's going to take a long time to do the processing of the payload. It doesn't take too long here. And then finally, I return the results to the caller. But I'm not actually returning the results to the caller at the time that it was invoked, and this is what we're going to talk about here. So now I've been my driver. So I've got the Mattermost server, or the Mattermost class that knows how to talk to the Mattermost cloud instance. But now I got the code that's actually going to execute the tests. And it's going to be invoking all these different methods. And here we have to keep track of what these methods are, because we're not going to get the results immediately. So I'm in queuing, and on the next slide, I'll talk about these methods there. But basically, I'm saying, OK, I want to run the login method. I'm going to give it the parameters, because these are all going to change based on the user that I'm running under. And when that's done, I can't make any further progress in my script until I get the login back. Just nothing else will work until I get an auth token. So the next line here says, OK, I'm going to wait until it's done. So here we go with those two methods. On the enqueue side, I'm just basically adding a future to an array. I'm just remembering that I've got something in flight, and I'm going to have to check back later to see what the result is. When I'm ready to check, I execute done. And now I'm asking the run loop to say, hey, don't continue on until all the stuff that's in the tasks array is complete, or it errored out or whatever. And so that's the async I/O wait there. Finally, I'm grabbing the results and returning them back to the caller in the invocation step. And a GET request is much the same. I'm not going to go here, but it's just that there's a GET verb, just like there's a POST verb. Now I can execute these things in parallel. These are independent requests, and so there's no tying of these requests together. I can say, oh, I need to fetch the roster of the people who are in the chat, who's in the chat, and fetch the posts that is in the chat, the latest posts. Those can happen independently, and I'm also creating a WebSocket, and I'm doing that in a little bit different way because of the way I'm finishing the test. So now I have a way of sending requests to my server, getting the responses back, going back and forth, going all the way through, getting everything there. Finally, I send a message because I want to test round trip time. I want to test logging in, getting all the updates, and then sending a message and seeing that message come back over the WebSocket. That's my definition of the test. Because that'll give me a good idea of how much time it takes to actually do all those steps. Now, as I mentioned earlier, I don't want each of our users, or these simulated users, to interfere with one another. So I'm spawning them. I'm using multiprocessing to basically run the run method as a separate process. I keep them all synced up, and I let them go on their way. Now that I've got all these processes running, they're going to do their thing. I need to actually collect the results. Or as in a map reduce, I'm doing the reduce step. So now I'm bringing back all the results together from these separate processes, and I'm generating a file. So this is just noise, but the p.join there is the actual multiprocessing, or the process method that is blocking until the process has returned. And here's a really not very clear slide, but I throw the data into IPython, and with pandas I can read it and see the elapsed times and the different stages, the overall time, which is off the screen. So that's pretty good. Well, real quick. The first column, or the third column here actually, is delay. And as I mentioned earlier, I don't want just users like every 1 second, every 2 seconds to come in and do a request. I actually want them just to be kind of random, but I want to be able to control the rate. I don't want them all to appear, so there's got to be some way I can specify that I would like some rate of users to appear and do some things on the server, while at the same time not keeping them lockstep. And that's what the Poisson process is. So again, we want a distribution of these intervals between when a user comes in. It's a completely random, that interval value. But we want on average that interval to be some value that we understand. So here's a hypothetical model. We have 10,000 users, and we want to run this simulation over 2 hours. That gives us a rate of 1.3, 1.4 users per second coming at our server and doing stuff. Or you can invert that and you get basically an interval of 0.7 seconds between users coming in. And that's, again, an average spacing. This is not guaranteed. It's not what you would see in the real world. So what can we do? Well, with a Poisson process, you basically you start with nothing happening, and as time progresses, the probability increases, the cumulative probability increases of an event actually taking place. It actually never goes to absolute to 1, but because there's always a chance of something else not happening, that's always a possibility. So you just keep waiting, you keep waiting, you keep waiting, and you can, using that interval, what you expected to see, which is this 0.72, you can, basically you would see a distribution, a normal distribution of your intervals laid out, centered around this 0.72 for very large numbers. And then, but each of the actual deltas would be all over the place, essentially. So on average, we expect to see 0.72 if we do a large sample. However, we can see users coming in almost simultaneously. We can see them spread out quite a bit, because those are non-zero probabilities. And so maybe this is a good thing to do, to say, well, geez, even though we, over historically, historical data, we've said, oh, we only see people coming in at 1.3 users a second. Well, maybe what happens when they all come in, when they wake up in the morning and they check our servers? And so maybe that's what we really should be looking at, rather than just say, oh, over average is 1.3. So how do we do those times I showed in that column a couple slides ago? Well, again, with it's an exponential. Poisson process has an exponential distribution for the times. And you can generate them using a log function together with a probability, a random value of 0 to 1. And this is taken from an IPython document that I'd created. And here's the only time I actually show is some NumPy, but it shows you how you could actually generate these values. And here I'm generating 1 to the 6th values, and I actually get the almost 0.72 response that I expect. So it looks pretty good. Now I have all these random deltas. How do I get to the times? Well, again, those are actually basically just add them up. So if I'm number 5 user in my simulation, and I'm going to run 100 users, and I have number 5, the easiest thing to do is he will start doing his thing at the time, which is the sum of the first 4 deltas that we calculated. And so you can just generate a running sum here in Python, or it's much easier to do in NumPy. Now, just to show you what those deltas look like, here's a plot of them. And you can see that overall, most of the stuff is below 1, which we would expect because of the point we saw over a large number of deltas. We should get about 0.72. So below 1 should be a majority of our deltas. But we do see, periodically some large gaps. All right. And we also have quite a bit of stuff way below 0.72. So here's some real-world measurements that I'd done for a customer. And it's hard to see on the side, but there's actually a decimal point. So for this was 100 users over 20 seconds. And the worst case was, some 3-second delay doing all that work. That was pretty nice. It was not too bad. They were happy with that. And we break it down into the actual individual steps, so we could see if there's any hotspots that perhaps we could do some caching to get rid of. Okay, let's look at 100 users over 10 seconds. Now we see now here we've gone to some worst, the spike here is at over 6 seconds it took for a user to actually do all that work. Which is not so good, but it actually didn't do so well overall. So maybe it's not so bad. And it still performed, it stood up, which is pretty nice to know. So that's basically it for my talk. There's additional information of the code. Like I said, is 250 lines. It's in GitHub at this address. My blog, Keystroke Countdown, has some additional information. It has the IPython pages that I clipped out in the presentation. And additional documentation is listed here. Finally, an excellent resource is the High Performance Python book, O'Reilly book. I highly recommend it. They do a really good job of explaining various reasons why you would go one way or the other in the async space. Really good. Any questions? Yeah. Oh, and I apologize if I talk too fast. And I'm a native English speaker.
How would you compare multiprocessing and async I/O?
Pardon me?
Well, I understand that multiprocessing is like simpler if you don't have shared data, and you have no problems with overhead of creating process.
Yes.
So I usually use multiprocessing. So, except these two cases, when would you recommend me to use async IO?
Well, I think you basically said it, right? So, so you're still with async IO. You still have, the guild to contend with. You still have. You're not just free will, just throwing a whole bunch of stuff out there. And a lot of stuff is not. In Python libraries, they're still migrating over to asynchronous implementations. So I basically know that AIO HTTP was going to be a very good high-performant means of executing HTTP transactions and getting high concurrency. So and since most of the, if you saw some of these requests take half a second, maybe up to a second. So during that time, the interpreter is fine to do whatever else it wants to do. So I think definitely in the networking space, async IO wins big time. Now, understanding the whole, the async and the await stuff, and what can you use, whether it's a futures or a generator or iterator, it makes me, gets me confused. I'm not used to it. So there was a steep learning curve from my point of view. But I think it was worth it. Now, I've done a lot of multiprocessing stuff, and it's the marshaling of the data between the processes that is the hardest to get right. And then once something fails, it all falls down, and it's hard to get everything restarted correctly, and because you have zombie processes sometimes hanging out. But it works. I think that since my requests in that whole list of requests, they were dependent upon the data that came back. So I had steps that I couldn't make forward progress until I got a response. In that case, I think it made sense to do the async IO. Doing multiprocessing, I'm just going to spin up a whole bunch of processes, and then I have to do the whole marshaling around of the intermediate data to make any further progress. And then I'm also incurring the latencies going over the net, doing that kind of stuff. So definitely for this kind of measurement, I think async IO is a big winner.
Thank you.
I'd like to ask you which libraries you have for plotting the data. You show the graphs. You have some nice.
Matplotlib.
Yeah. Okay.
Yeah, it was part of IPython, so it works pretty well. But it's actually you could tweak it, all right. But so what you see on the web is much better than what you got here because of the loss of detail. And plus, I was basically cutting images. So.
Okay, thank you.
Thanks. Okay, how would you test an application that has WebSockets and REST as well, but they're dependent from one each other? For example, you create a user does an action, and something is thrown to a WebSocket. I want to test the delta in between, those things which are completely different. I don't know if I made myself clear.
No, yeah, sure. So yeah, I did not talk about the WebSocket other than I alluded to that I am actually using a WebSocket. And at one part, after I've gotten the authentication, I know some other information, I can finally start a WebSocket. Parts of code that I did not show is actually the termination step for my test. And so I'm doing all this setup, I'm getting all the data from the server, and my final measurement is to do a post HTTP post, send a new message to the server. And I've already stood up this WebSocket, and the WebSocket will receive that new notification. That's how Mattermost conveys or keeps people, happy in real time using WebSocket. And there's support in the WebSocket protocol, or the implementation I'm using. And I can't remember right now if it's a separate piece of code or it's the part of AIO HTTP. But I'm basically waiting, using async stuff, to see what data comes back over that WebSocket. I ignore some stuff because when I'm logging in, I actually see myself logging in and being part of that channel. And so when I send that message, all I'm doing is just waiting in a future until I see my own message come back. And I've got the round trip. And so you can easily do that with async IO. And again, I'm not sure, in the slides on the last one, there's a link to GitHub gist that actually you can see the code that uses the WebSocket stuff.
I think you could show the slide.
Yeah, let me, or I can, do we actually post the slides? Yeah.
Right, do we have any more questions? Looks like no. So thank you.
All right, thank you.
After the break. So my favorite part of the conference is always the lightning talks. And I saw that there's not enough of you signed up for the lightning talks. So please, if you have anything to share for 5 minutes or even half a minute, go there and sign up. It'll be fun. And I think there are still tickets for the workshops if you want to go to workshops on Saturday. And with that, it's always a pleasure to introduce Jarka Schovancová, who has a PhD in nuclear physics and is doing Python instead. I don't know why. So she's doing monitoring, commissioning, and testing of infrastructure for the Large Hadron Collider. Please welcome Jarka.
Good afternoon, everybody. I am Jarka. I work at CERN as a computing engineer. Even though I have background in physics, I am currently focusing on the IT part of physics or physics applications. So today, I would like to tell you what I'm doing at CERN with some updates since last time. And I will start my talk with saying what CERN is. CERN is a laboratory. It's the coolest place in the universe because it's a laboratory with Large Hadron Collider, which operates at a temperature which is very, very few degrees above the absolute zero. So this is projection of the biggest accelerator in the world on the map or aerial view of Geneva and surrounding. Unfortunately, I don't have a pointer, so I'll be trying to do some shadows on the slide. Here, behind me, you can see Geneva Airport. This area upstairs is Lake Le Mans. Some people call it Geneva Lake, but the locals around Geneva and outside Geneva don't like this name. So it's Lake Le Mans. And you can see some fields, houses, and white circles projected on the map. So these white circles are a complex of the accelerators which contribute to accelerating particles which are colliding in the Large Hadron Collider. Here on the bottom, some of you may see it, some of you cannot, I'm sorry, is the main campus of CERN. This is area roughly 2 kilometers in length. And there is a first half or first part of the chain of the accelerators. It's really a chain. It's not just one large machine working for us. There are many machines, like more than 5. And each of them contributes a bit, accelerates the particles a bit. And the particles that gets faster and faster. And in the end, it's accelerating in the Large Hadron Collider, which is the biggest circle around here, which has circumference of about 27 kilometers. So to see what is the size of this picture or the scale, from here to here, you have roughly 13 kilometers by car, by bike, or walking. So this is very, very nice area. It's close to the lake, so if you like sailing, you can have your boat there or go sail on some of your friend's boat. If you like hiking in mountains, on the other side, here this dark green part behind the CERN logo, there is a Jura mountain, which is about the highest part is, I think, 1,500 meters above the sea level. So it's almost Snezhka. So it's really a very nice area. If there is no clouds, you can see Mount Blanc, which is the highest mountain in Europe, when you are going to work. It's really nice. So back to the picture, back to the white lines. I will be speaking about monitoring of computing infrastructure for the physicists who are doing science based on the collisions of particles in the largest line or largest circle. This is, on the previous picture you saw the projection, And on the left side, your left side, my right side, you can see a projection of the Large Hadron Collider, which is accelerator which collides hadrons, for example, protons with protons, or protons with lead ions, or lead ions with lead ions. And the chain of accelerators accelerates these particles, the protons, for up to the 0.999999996 of speed of light. So it's not the speed of light, but it's very close. However, we can never get with accelerating massive particles to the speed of light, because we would need infinite amount of energy to do that, and we do not get this energy. We do not have it. So we have this accelerator chain, and we are accelerating particles. They are running particles in circles, and they are colliding in 4 points. These 4 points are here, 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 and here. They are called interaction points. And around these interaction points, there are detectors. This sounds like camera for physicists. It's a very big camera. On these pictures behind me, you can see the 4 experiments, which are those detectors. Unfortunately, we don't have banana for scale, but we have humans for scale. Somewhere here and here. So you can imagine these are really very big detectors. If I would like to compare, let's say, the Atlas experiment to this room, then maybe this room would reach half of the height of the Atlas experiment. So these are really very huge machines. They are full of technology, which has to survive all the radiation which is coming from the colliding particles. And we are detecting physics processes. We are detecting lots of them, like billions of them per second. And we have to be able to filter them and to process only those which are interesting, which are something new, or which are improving our knowledge of universe. And to do this, we need lots of computers. Now it's first time for movies. So I hope you can see it. This is a picture of the projections of the accelerators. Again, you can see this big circle, Large Hadron Collider. And you can see some orange dots, which are traveling in both directions. And then they are colliding. You can see small flashes in the place of the detectors. I will play it again. So, for example, on the bottom in Atlas, you can see 2 bunches colliding. There is some light. And this light is something we study. So now this is a close-up to what happens when the 2 bunches collide. These bunches, these are not 1 protons. These are 10 to 24 protons, so 1 and 24 zeros of protons together in each direction. And they are, the bunches are spaced with so small distance that it takes about 25 nanoseconds, 25 of billionths of seconds to hit one, hit the next one. And when these bunches from opposite directions, from opposite beams collide, they interact on the, let's say, subatomic level, and they create shower in the detector. And depending on what type of particles compose this shower, these particles are detected in different parts of the detector. It means in different distance from the place when it exploded. And physicists then study these explosions. We call it events. And we are interested only in the events which have not been observed before so much that they have been understood very well, in order to find either improvements of the current theory of subparticle physics, or particle physics, or in order to see what is behind the knowledge of the theory we have. So let's proceed further with the slides. This is a picture of an event. You can see these red lines here, and here. There are 4 altogether. And this picture is important because this is a candidate of, let's say, Higgs boson event. Higgs boson decaying into 4 muons. The muons are the red lines, which are exploding or going further from the big circle. And then you can see lots of lines which are orange, then some dots which are white. And you can see around the circumference of the circle, you can see how much energy was deposited in this direction. These are probably some jets. So this is just one event, and I told you that we are having something like 1 billion of them per second. So this is another event, again, Higgs candidate with 4 muons. The muons here are the blue lines going in opposite direction in pairs. And the important thing is particle physics started, let's say, in early 20th century. And back then, we were studying processes which were very low energy, such as studying atom of hydrogen, electrons, and so on. And now we know these low energy processes very well, so we do not need to study them anymore that much. We know they are there, but now it's our background. We don't care. We just throw it away. What we do not throw away are the events which need lots of energy, very fast particles colliding in order to occur. And these are all probabilistic events. So we have to make so many collisions and collisions of fast particles to make sure that, according to theory, we will be able to observe so many events like this, like the picture I'm showing. And in order to do that, we are using large computing infrastructure. We call it worldwide LHC computing grid. And this is a set of over 170 data centers distributed worldwide. Each of the green points is mapping one of the data centers. These data centers are in over 42 countries, and together provide over 600,000 CPU cores that physicists use to analyze the data. Because what we need to do is we need to read out the data from the detector, then assign some physics meaning to each of the data points we get, and then study these events to, let's say, make these pictures or make signatures of the pictures, understand the signatures, and then collect some statistics about them. We currently have over 400 petabytes of disk. Each year, we produce over 35 petabytes of raw data. So the scale of how many processors we need, how much disk and tape we need is quite large. And it's so large that not a single scientific institute can afford this on their own. So we are collaborating. We are collaborating with many institutes together. And together, we are studying new processes in physics beyond our current knowledge. Now it's time for a second video. So this is an animation from Google Earth with real data taken this morning. These green lines are data links. And you can see that there are some blue lines moving, violet lines moving. And these blue and violet lines are, let's say, data which is sent to some data center where the calculation or analysis is running. Now, you can see Prague is here. CERN is here. It's roughly 1,000 kilometers by car or 700 kilometers by plane. And in Prague, we have a tier 2 data center, which is called Pratt LCG2. And in this data center, we are analyzing data from Atlas and ALICE experiments. Atlas is one of the generous purpose detectors on LHC, and ALICE is a detector which is interested in heavy ion physics. So you can see in the morning we had over 280,000 simultaneously running jobs, which took almost 500,000 cores. And we were transferring data as an input for the computational job or as an output at the rate of 11.52 gigabit per second. OK, I will go back to the presentation. Now, the challenges for computing, we have to keep in mind the goal. The goal is to support physics analysis for the LHC experiments, to be able to further knowledge of fundamental physics. And for that, as I showed you, we are using worldwide distributed infrastructure, which comes with the challenges of how do we economically set up those data centers, how do we operate them, how do we solve problems with connectivity between these data centers, and so on. We have limited resources. It's public science. And we have very high demand from the physicists. So we have always battle between physicists need to produce simulations or analyze data with very high precision. And they cannot do it because at the same time because the resources are limited, are sparse, and we have to prioritize. The physicists have to decide what is the priority of the project in order to achieve the goal. And to do that, we have pledged and opportunistic resources. Pledged resources are those which each institute pledge to provide, and then they provide it. They find funding for them and provide it to the collaboration. And opportunistic resources are the resources which can be, let's say, paid by someone else or volunteered by someone else. Now, we have to deal with security because this is a large infrastructure which has over 15,000 customers, or up to 15,000 customers. We need to operate it in a sustainable way. We need to work on development of different components of the distributed computing system and make sure that this system is sustainable and addresses what we need. And we need to work on optimization of the software because the resources are scarce, and we need to test the resources and monitor them. And for the monitoring and testing, we are using several tools. One of them is WLCG HammerCloud. WLCG stands for Worldwide LHC Computing Grid. HammerCloud because it's hammering clouds. The cloud does not mean cloud in cloud computing. Originally, it meant geographical area in the world. But now it can mean also cloud computing. So HammerCloud is a Django application, Django-based application, which is being currently developed in CERN-IT with collaboration with experts from the experiments so that we can provide useful service for the experiments. What we do is we have a small cluster of about 20 machines which create this HammerCloud testing infrastructure. This one. And we run these machines on a CERN Agile infrastructure, which is OpenStack-based. For the environment for these machines, we use scientific Linux. And we are currently moving, we are close to finish this migration to CentOS 7. For submission backend, last year we moved to a combination of Celery and Redis so that we can distribute the submission load across the cluster. The submission load is not so heavy, but we are submitting something like over 180,000 jobs per day in different 100 tests. We are submitting to different front ends. These are workload management systems of the experiments. Workload management systems are the machineries which can interface between a physicist and the infrastructure for computing used by the experiment. They separate the workload into units, into jobs, and these jobs are then executed on the work node or on the cluster from data center. Recently, we introduced a new submission front end, which is one type of batch systems which are used in high-energy physics community. And all these jobs are submitted to WSEG, to Worldwide LHC Computing Grid, and then they are executed. Now, what we do with these jobs? This tool is for monitoring of the infrastructure, and we monitor the infrastructure with the very realistic workload. This is no mockup. We have, let's say, templates which define which workload we will run, and these templates are doing the same thing as normal analysis job. So it means if this template job, this test job or monitoring job fails, there is something broken with the infrastructure, because we set the templates in the way that it shouldn't be misconfigured for this. And in this table, you can see 3 lines. Each line represents one template. And we are running jobs, which are these computational units of work. And in some intervals of half an hour, there are different results of these jobs, different exit codes. So if the job succeeds, we mark it with C and green as completed. If there is no job which finished, but there were some submitted, we mark it with yellow and S. And if the job fails, we mark it with red F. Now, we have some policies which excludes the resources automatically. If the job fails afterwards, based on the policy, we exclude the resource. We keep running the tests, the monitoring tests, and according to policy, when there are no more failures, or they are in acceptably low level, we recover the resource again. And we do this all automatically. This is very useful because it saves lots of manpower from the operations team, and it can point out what is wrong with the site, and the site administrator can then fix it. And at the same time, the users, the physicists, are not exposed to this failing infrastructure. Now, this is the scale of automated resource exclusion and recovery for this Hammercloud tool. In blue line, there is the map of recovery, or histogram of recovery. In red line, exclusion. You can see we are doing something like between 200 and 400 recoveries and exclusions per month. Each of the bins is 1 month. So it really, you don't have to waste money on people doing something which you can automate. It's very useful. And very recently, we introduced this batch system possibility of submission of this test. Now, this is very, very exciting because when you are a site admin and you are, let's say, pressed to publish your resources as production ready as soon as possible to fix all the problems and make them available, then sometimes happens that you think the infrastructure is ready, but in fact it's not. The experiment jobs are failing. So we introduced new feature which enables, let's say, pre-commissioning of the resources to try out that your site is really ready before you say it's done. This is very useful because it saves manpower both on the site admin side. It saves money because we are not burning CPU cycles with failing jobs, and it saves manpower on the operations team side. Now, if you are interested in data mining of the dataset of physics data collected at CERN, there is a project of CERN Open Data, which publishes a dataset where you can either educate yourself or educate your students, or you can do research on real CERN data. So if you are interested, opendata.cern.ch. And if you are interested in collaborating with physicists from CERN, you can contribute by providing resources for working computing. If you have a look at your favorite search engine and look at LHC at home, you will find this web page. And you can join something, some project based on Boeing. OK, thank you very much.
Thank you. And we have some questions. The first and obvious one is, what does it take to become an LHC IT engineer? Do you hire?
Yes, we do. We have different programs at CERN to hire people with different backgrounds and different expertise or experience. If you search for CERN jobs, there is a web page which provides the overview of all the information and also information about open positions. So I invite you to have a look.
Thank you. And are the people working there both good computer programmers and physics scientists? Can we be sure that the algorithms are not inefficiently programmed?
Yeah, there is a saying that physicists make very bad programmers. Sometimes it's true, sometimes not. It really depends on the person. You cannot mark people just by their education. In CERN IT and at CERN, there are people with physics background, with computer science background, with computing background, and we work together. We are trying to bring the best of us. We are learning on the job. We are educating ourselves continuously. So in CERN IT, you can have physicists or former physicists doing programming work and doing a great job. For what concerns the efficiency or inefficiency of programs, yes, if you have a PhD student who met C++ programming a week ago, perhaps his code will not be the most efficient, but the point is that it does the job. And when the student moves his analysis to this large-scale computing infrastructure, we make sure that he gets help, he finds help, and none of the work is done in a single person. We are teams. So on each of the analyses, there can be from few, let's say less than 10, to several tens of people who are doing the same thing and who are working, let's say, in an open source manner, who share the code, share the knowledge, discuss the problems, and try to help each other.
Thank you. And how perfect is the LHC circle? Was there a requirement to build a perfect circle, or does it not matter?
Actually, the circle is done with electromagnetic field. The building blocks are straight lines of the length of, I think, 10 meters. And there are really many of them to make the 27 kilometers of the circle. So for what concerns the beam pipe, it's bent, but the building blocks are straight, connected with some connectors. But nevertheless, the beams are so perfect circle that you can see if there was a difference in some direction of several microns, you would see it. We have this monitor of beams, and there is you can Google it on LHC page 1 and similar pages from LHC and beam pipes. There is this detector which projects, let's say, how focused is the beam and what is its position when it's circulating. And you may remember, or you may have seen on YouTube videos, when people were sending the very first beam with very low energy, and they were very happy when the beam ran in one round, and it was in the same screen, both ends of the projected beam. So this is really hardcore science to make sure that the beam is focused as thin as possible, when we are doing these collisions, these runs can take several tens of hours. So it starts as a very laser-focused beam, and it splits a bit. So at some point, we kill the beam, and we start over, so that we make the perfect circle or a projection of the circle. It's actually not continuous circle. There is plenty of vacuum in between. It's a bunch, 25 nanoseconds, nothing, bunch, 25 nanoseconds, nothing, bunch. So it's like, I don't know, the coral for your neck or necklace.
If I can ask for a very quick answer, the CERN data appeared in a Kaggle competition some time ago. Is there CERN open data available as Kaggle data sheets?
I hope so. I'm sorry, I'm not sure. I cannot say it for sure, but there were, I think, at least 2 or 3 competitions with CERN-related data from different experiments a couple of years ago. And I think the Open Data Initiative is very, very keen of these competitions. So I hope so.
Right. Thank you, Jarkka.
Thank you.
And if there are any lightning talk speakers, I would like to ask you to come to the front and sit somewhere around here. We'll try to make the switches as fast as possible.
The lightning talks will be starting in a moment.
If you are a speaker, please sit in the front row so you'll be available. When I call your name, please use that, well, either jump up or use that door to go to backstage and enter the stage so you'll get here. The rules of the lightning talks, you get 5 minutes. You can say anything you want as long as you stick to the code of conduct and stuff. After the 5 minutes, if you're not done, you will get hit by a rubber chicken. And yeah, I guess that's it. Have fun. First lightning talk is syntax highlighting in presentations by Viktor Stiskala, and I would like to ask L. Lozinski to come up to the stage.
So, hello everyone. My name is Viktor Stiskala. I'm a CTO at fintech startup Twisto, and I also sometimes speak at conferences. And today I have seen many great talks, but sometimes with poorly readable code or without syntax highlighting at all. So I just wanted to show you something. First of all, please don't use screenshots of the source code. It may look great on your screen, but if it's displayed on a different resolution, it doesn't look that great. And many of you are probably Python developers, right? So why don't we use Python for that? And this is a short demonstration of pygments and how can you highlight the source code in your presentation. So I will just copy the code, open some editor and save it to a file. After that, I will call a short script it's called pygmentize. I'll show the commands later. And with this command, it's copied into the clipboard. And I can directly insert it into presentation if I'm on Mac. This is one of the examples. And yes, that's it. And the code is inserted into the presentation. And if you're on Linux, you can use pygments to export the source code the same way, but into the SVG file. And yes, this is the same story. You will just insert the code. Then a single command. Export it into a SVG file and then import it into LibreOffice or OpenOffice or whatever you use on on your Linux. So yes, that's it. The huge benefit of it is, of course, it's in vector, so it can scale easily, and the result could look something like that. And yes, that's only one line of code which you have to use. The first example is for Mac. You can use pbcopy to just copy the output into the clipboard, and the later example is into the SVG file. And the pygments also supports Python console highlighting. So in the next example, you can see how it looks like in interactive mode console. So that's it. Thank you very much.
Thank you. All right. So please put it in there. All right. So we will have a lightning talk titled pythonlinks.info by, what's your name?
Christopher Lozinski.
Christopher Lozinski. I thought it was an L, it's a C. All right, and I would like to ask Maciej Sulik to come up to the stage or wait in the backstage just to see you're ready. So, does USB work today?
Yes.
Almost there, almost there. There we go. All right. Microphone is here, and it's all yours.
Hello, Christopher Lozinski here. Sorry, how does this work? There we go. I run pythonlinks.info. It's the world's largest Python directory. If you do a search for Python, you get snakes and Monty Python and all kinds of other stuff. It's actually 190 million items. It's a flat list. It's just too many to go through. Sure, you can add additional keywords, but a much better approach is to organize information as a hierarchy of catalogs and ontology. Librarians have been doing this for centuries. If you know Yahoo Directory or DMOZ, they did the same thing. Python Links does this. It has different content types, categories, links, YouTube videos. There are a bunch of other content types I'll mention in a minute. It looks like it's just a 4-level tree, but actually different branches go down different depths. Some branches go down as much as 8 levels, 7 items in each level. 7 to the 8th is about 500,000 items. So let's take a look at one leaf of the tree. This is for ZODB. ZODB is a wonderful object-oriented database written in Python, just subclass off of persistent, and your application becomes persistent. It's amazing more people don't know about it. Brilliant software, check it out. Here on the tree, where are we? Python links, Python software, Python libraries, database libraries, persistent Python, ZODB, ZODB introductory video. So very easy to find stuff, easy to organize, but nobody cared about all of this because it doesn't hit them in the pocketbook. So I went and I did one for iOS and I did one for Poland Trade. And the discovery is if you do something that's related to business, people really care. So I built another set of content types. The world, Europe, cities, countries, England, cities, London, company, Monzo, and within that you can find their jobs, links to their blogs, review articles. Glassdoor often reviews what it's like to be a company, to work at a company, and everybody likes this. So here's a table of the companies. Actually, this is FinTech in Poland with the cities. On the left-hand side, you have the company name, a link to the company. On the right-hand side, what it specializes, and all kinds of additional information in there. Somebody asked me today, can I supply this as a JSON feed? Well, it's a tree. So I can supply the JSON feed of companies in Prague or Brno, or I can do one for all of Czech. And then it's very easy for all the user groups to just add this information. The lines that are green are the companies that have jobs, so you'll see those on any job board. But if you're coming to a city, you want to know all the companies and what they're doing, and if it's interesting. Even if they're not hiring, you want to see that information. So it's particularly good for beginners, these content directories, because if you're a beginner, you don't even know the names of the libraries to search for, and you don't have any idea what the local companies are. But it's good for everybody. It's very fast, so probably a bunch of people, it's run on Python servers, JavaScript clients, on scalable Linode servers, behind Nginx. Did it stay up during this presentation? Yes, no? Is it up? Nobody's using it? Pardon? No, is it my website? Because often people will browse when I'm talking, so. Oh, well, that's not my fault. My servers are up. And I did one for Poland, so if you're interested in moving to Poland or something, as I know a lot about trade with Poland, I invite you to, if you go to the website and you click on Contact, if you follow me on Twitter, then I will link to your company. I'm also going around, if you invite me to come to your user group, I'd be very happy to travel anywhere in the anywhere in Europe. Thank you very much. And there's no chicken, so I'll take the, I'll do one more slide here. There's so much noise on the web, right? And so what you have to do is you have to get good sources of data. And so what this is actually, it's not only a content management system, it's a content aggregation system. For example, in Czech, there's a database, there's a JSON file on GitHub of all the Czech companies. So I suck that in. So I suck in data from lots of places, and then what I do is I merge the tree. Is that the chicken? Okay, thank you.
Okay, sorry for that. I didn't mention it. There's a timer up there, so that was the 30-second mark. So theoretically, you could.
I get another 30 seconds. Let's see. You know.
Yeah, dance. That's a good way to spend a lightning talk. All right. Can you set up? Do you have HDMI?
No.
No. What do you have?
Somebody said, who's a VNA? VGA? Yeah. All right. I got you. All right, so some people don't have VGA. I'm one of them, by the way. So this lightning talk will be about bugs, Python org, and you by Maciej. And the next lightning talk will be what by Adam Jerzek, probably. Could that person go in the backstage or up to the stage? Oh, it's you. Oh, okay. Should have known that. All right, I think we are set up. So take it away. Oh, sorry.
Hi, I'm Maciej. How many of you know this address or have been to this address? Just a few? Okay, so this is the place where you actually issue or fill in every problems that you have with Python. CPython in majority, because that's where it's devoted to. But unfortunately, all the fame goes to CPython developers because they are so cool. They are core developers and working on CPython itself. And there is a bunch of just a few people that are actually maintaining BugsPython.org itself. I'll present you the address of the bug tracker that we have for BugsPython.org at the end, but generally we'll talk about it a little bit more in a moment. Since we moved to GitHub, if you're interested in why we are not using GitHub for issues, catch me up afterwards or tomorrow, and I'll explain you in detail why we're sticking with BugsPython.org and Roundup. Oh, this is the other thing that I haven't mentioned yet, which is Roundup is the software that is behind BugsPython.org. So currently, during past 2 years, we did a lot of work around integrating BugsPython.org with GitHub. So currently, you can link easily issues on GitHub with comments and issue title and PR titles and PR reviews as well. So if you use BPO dash and the number of the BugsPython.org issue number, it will be automatically linked to the issue in the BugsPython.org. Yeah, there's a limit to 10 because we had some problems with flooding our BugsPython.org with some mistaken issues. Additionally, it also closes some issues, or depending on the comment in the comment message. Like I said, 2 years ago, we had a very smart Google Summer of Code student who helped us out to create a Docker image for running BugsPython.org. So currently it's so much easier to run BugsPython.org locally and actually work on it. So I totally encourage you to do so. This is the short version how actually you can run BugsPython.org. Unfortunately, the current version is a little bit longer. There are a few more steps required. You need to have Roundup, Python dev, repos cloned locally. Unfortunately, you still need to build the Docker BPO image locally because we haven't published it under Python organization on Docker Hub, which is happening in the next couple days, I'm hoping for. And if you're using Linux, don't forget to add :z. So that's basically it. This is the address, the URL under which the actual bug tracker for the bug tracker is. So I totally encourage, if you're having problems with BugsPython.org but not Python, this is where you should fill in issues. If you have problems with Python, go to BugsPython.org. If you have problems with BugsPython.org itself, go to this address. I'll be very happy if somebody is interested in helping up with BugsPython.org. There's a lot of work to be done, a lot of issues. I personally hoping to work on OAuth integration because we are currently having some serious problems with, for example, Google authentication. If my personal story was that I was helping somebody because he was complaining that he removed his Google OAuth integration, and and he couldn't restore it, and I'm unfortunately in the same state because I removed mine and I can't restore it yet. So we need to work on that one. There's GitHub auth integration as well, and there's some plan to move to a new servers with BugsPython.org that will be actually managed by the PSF and not some external company. That's pretty much it. Thanks.
Thank you. Thank you. Thank you. So these are very quick lightning talks. I don't have time to use my chicken. So next up. Yes? Question. Question. Lightning talks generally don't have questions, but if there's time, you can ask something, unless the speaker already left, which is the case, unfortunately. So, oh, you're still here. So we don't have any time. Sorry. So somebody asked a question. Could I ask Adam? Come up. We have VGA again, I think. So I hope we'll get set up fairly quickly. And can I ask Jirka U or Jirka V to go to backstage and be ready for the 20 lines of PyCode. So this talk will be what? This will be on the screen. Okay, can we switch to the screen? Perfect, all right. So here's the mic. And take it away. Oh, yeah, sorry.
So I'm Adam Ježek, I'm a student, and some time ago I saw a lightning talk by Gary Bernard talking about the what's in JavaScript. And I thought if there's something similar in Python, so I did some research. I suggest you all know what is what. Yeah. So, so let's start with something simple like Boolean operators. Yeah. You all know true is true, false is not. False is not true, and option. Is it fine now? Yeah. Okay, so let's have this piece of code in false. Who knows what this is going to be? True or false? False. Of course, false. So if we modify it to this, what is this going to be? False again. Right. And who knows what is this going to be? Yeah, of course it's true. Yeah, what? So, yeah, screenshots during presentation. Yeah. So why does it happen? So in and yeah, they are both comparison operators, but they have the similar priority. So the code is translated like false is false and false in false. So it's of course true. So another thing, indexing. Okay? If you have a list of one item, you can index with numbers. Yeah? And if you try index with decimal numbers, it's of course error. But if you have a Python dictionary, you can also index with you can also index with numbers. But if you try to index with decimal numbers, it suddenly works. What? You know, not a number types. Yeah? If you have not a number, and another, not a number, you know, they are not equal. if you try to assign them in a list, but some nuns are not equal, but some are more unequal than the others. Yeah, so this is, for some reason, true. We don't have much time, so you all know what is a set, a list of unique items. Yeah, this is. Length of this is 3, and if you add more items that repeat, it's again 3. So if you have length of x, float x, I think we don't have time about it, so forget about it.
What?
Forget about it. Python also has infinity. So what do you think this is going to be? Infinity minus infinity should be 0, should be 1, should be minus 1? Does anybody know? Yeah, maybe this could help you. Upper. God, 15 plus. Still don't know? Thank you.
All right, thank you, Adam. Another lightning talk. And now we will have the 20 lines of Python code I'm most proud of by Irka. So just a while until he gets set up. What do you need?
HDMI.
Oh, right, it's there. All right. I wonder when the world will standardize on one display connector. Okay, and we are almost on. All right, there we go. Here's your mic. Take it away.
I realize I'm the last one standing between you and beer, so my apologies. I recently estimated I wrote between 50,000 and 80,000 lines of code on Python in my life, and I'm going to show you the 20 ones I'm the most proud of. These. The question is, who in the room would be able to write that? I guess pretty much everyone. It's not really too complicated. If you think you could write it, raise your hand. I'm going to be disappointed. It's basically basic Python. What it does is I had to fit it into columns, but basically comparing two different strings and see how different they are, or more likely, looking for the ones that are the most matching. The reason I'm most proud of that is because I met a doctor. And she was a highly qualified doctor at the peak of her career. She was basically a lead scientist at the hospital. And her job was to take this. What's that? It's a DNA, more specifically a human DNA. And that's what its DNA is supposed to look like. That's a healthy patient, a section of DNA for a healthy patient. And she had a very expensive machine. And the machine was basically taking a new human DNA and producing something like that. The problem was that the patient wasn't always healthy, and some parts of the DNA, one single letter was flipped, and the machine would produce something like that. The problem is it doesn't really start at the same exact offset. So it could start, 5 letters missing, 50 letters missing, 500 letters missing. Who can tell me what's the difference? Which letters are flipped between this and that? I'll keep flipping over until somebody says, I know it. Come on, doctor can do it, you're programmers.
Is it a C?
Might be. Yeah, obviously humans are not supposed to do that. And she spent something like 4 hours a week doing exactly this. Printing one, printing the other, and looking for differences. It's a huge waste of time. Unfortunately, that's basically how sometimes Czech hospitals work. There's no IT staff, and doctors do these stupid tasks. So I wrote a code. I wrote exactly those 20 lines, something around those kind of printing stuff, but it basically gives her that. That's the result. What I'm seeing this story is that really the code isn't great. It's pretty stupid, to be honest, but it works. And it can produce the result in like 0.2 seconds, maybe less. And it saves her about 4 hours a week. What I'm trying to say is you don't have to write perfect code. It doesn't have to be super awesome. It doesn't even have to be commented sometimes. You can be a student and learn Python, and you probably can write something that's going to save somebody a lot of time. So if you can, do it, please. That's it. Beer.
Thank you. And so now we have a blank spot on this page, but fortunately, we have a last-minute presentation by Bhargav. I have no idea what he'll talk about, so it'll be a surprise. And here it is. You have the mic here. And can we switch the screen to hello? Hello? There it is.
Hello?
Take it away.
So I'm going to first start talking about, can you hear me? Okay, yeah. Cool. I'm going to start talking about the Google Summer of Code program. Are there any students in the crowd? Students, hands up. Whew, awesome, cool. So what exactly is it? Well, students contribute to open source projects which are selected by Google. This has been happening since 2005, I think. I could be wrong, but yeah, for a while now. And you basically, like the name suggests, Google Summer of Code, you spend your summer coding for an open source organization chosen by Google. Now, why this is relevant to all the students in the crowd? Well, you learn a lot. It's a lot of fun. You usually work with really big organizations, like Mozilla is one of them. And, well, of course, you contribute open source, which I think is the most important part of coding in Python. And there's a lot of data science and Python-related projects. PSF, which is the Python Software Foundation, is actually a part of the Google Summer of Code program. So if any of you guys already, or girls, if you already contribute to open source Python organizations, you should check if they ever took part with Google Summer of Code. And you get money, and since students are poor, then it's always good for us. And for mentors, why it's useful? Because you expand your project community. You sort of get students to want to start contributing to your communities. You get people to start with open source. I think it's really important for everyone to give back to the community, especially given how much it's done for us. And for students to start, it's awesome because you start early. You also improve the quality of your package because you have conversations between students and between mentors. And you're going to help a poor student if you're a mentor. So you're going to make people happy. More details. Sadly, the deadline for 2017 is over because summer's already started, which you can see the lovely weather. But please apply next year, either as a student or a mentoring organization. If any of you have a GitHub repo with Python code in it, just submit it to Google. And the shameless plugin for anyone hiring data scientists. I'm a 2-time Google Summer of Code student, so hire me. That's the end of the first talk. So check it out, Google Summer of Code. Really cool program, lots of money, lots of learning, lots of open source, and lots of Python. The second mini lightning talk I'll be doing is about a package called PyCobra. What is it? I'm assuming a lot of people that have done some machine learning or data science stuff out here, a fair amount of people. For those people, PyCobra is a Python package for regression analysis. It compares different machines or regression machines, which are like basic machine learning algorithms, and it combines them. You can visualize the result of your different machines that you're using, so you can actually see how each of your machines stack up and how well they perform compared to each other. Why you should use it, I wrote it. It'd be cool if you guys could. Also, it's a cool way for beginners to get used to regression. I think if you're just starting off with machine learning and open source in general, and you want to see what it's all about, check out PyCobra. And it's built on scikit-learn. So scikit-learn is the most, I think, important machine learning package out there. So if you already started using scikit-learn, then it's built on top of it. It's very similar. It's the syntax, the API is really close to it. And it has a bunch of notebooks and tests, lots of examples, and I think it's okay. More details, it would be really cool if you could star, fork, or whatever. It's Bhargav Vader is my GitHub repository, and PyCobra is the name. And the algorithm which is used to visualize and to aggregate these machines is from this research paper, which is called Cobra, a Combined Regression Strategy. Also, PyCobra has 2 snakes in it, which I thought was pretty cool, PyCobra. And, well, that's it. Thank you.
thank you. So, lightning talks within a lightning talk. All right, so your presentation is up here.
Like every year, I'm going to talk about GIS to enlighten you a little bit. Yeah. Thanks. Great. So let's talk about GIS very fast. Like every year, the same presentation. My name is Joachim, and I do GIS and Python. Usually, well, at the beginning, I was a forester, but it doesn't matter anymore. Let's talk about GIS and Python, of course, and the open source software. What is GIS about? It's about maps, it's geographical information systems. So basically, we are dealing with data which are located somewhere on the Earth, usually on the Earth or on the Mars or whatever. But we know definitely where they are, because it matters where we are right now, where the stuff is happening, where the phenomena are happening. What is GIS about? It's about image processing or raster data processing. It's about databases. It's about vector data manipulation, cartography, 3D graphics, and more. GIS are running on servers, and there is a software for it on desktops, of course, and of course in the web browsers. Everybody's using Google Maps, right? Not only them. But usually we are not speaking about Python in terms of web browser. Luckily. The most important starting point for you is the address joepython.github.io, I believe, where you can find most of the open source Pythonish GIS packages. Because Python loves GIS, and GIS, of course, loves Python. This is the most geo-positive programming language right now out there. There's lots of projects going, and there is lots of happenings. You get a point. Together, all the tools are building a very solid plate. Come to my workshop on Saturday, and if you don't come, everything is documented either in Czech language or in English. And you can visit our GitHub because we are GIS mentors. Thanks. That's all.
Thank you, Joachim. And unless somebody else wants to come up, we will have the last lightning talk / organizational talk from Kubik, who is just getting set up. And something appeared. Something different appeared on the screen. Okay. So how do you set up mirroring on this computer? I don't think that would work. All right, so, well, the Lightning Talk sign-up sheet is not full, so we have lots and lots of time for you to watch Mac shenanigans. And is it just to show one link? Yes. Ah. How many engineers does it take to show a link on a Mac? Okay, perfect. Keep it there. And here's your mic. You have 5 minutes.
Cool. Hey. So this applause, I believe that was for the speakers, for all of you. Thanks. Thanks for the day one. And I'm looking forward for day two as well. You did an awesome job. It was great. Thank you very much. If you are a speaker, if I can ask you to gather outside right after we finish, right now, we can take a picture and then we can walk to a speaker's dinner. Because you deserve it, right? Do the speakers deserve some food? What do you think? Me, the guy with the sock, I can help you get to the place. If you are not a speaker, of course you want to have some fun. So we put one advice for you. It's super near. If you go to the link, and if I can click it. No, I cannot. I have no idea where the pointer is. Oh, there you go. Oh, you really would like to see the source code of this page. I just set it up. There's a nice bar. It's called Uperonu. It's near the train station. So it's like 3 tram stops away from here. Go there. You will have a lot of fun. And after the speaker dinner, maybe we will be able to meet somewhere. There are some channels that we can get in touch. So see you. And if not tonight, see you tomorrow.
Can you make the font bigger? Můžeš zvětšit font. Zvětšit font.
Do what?
Zvětšit font. Make the font bigger.
Yes.
All right, and I believe that is it for the lightning talks. So thank you, everybody, for a perfect first day. See you at the dinner or the beer. One last thing, if you were a speaker and didn't sign our board, please do that. It would make us very happy. Otherwise, see you, everybody, tomorrow, and have a good time.